So this is the where ultimate engineering requirement comes into picture. So when you can increase the flight time. So when you can increase the flight time usually depends upon the weight and aerodynamic drag. If you can decrease the weight and if you can decrease the aerodynamic drag, automatically your flight endurance increases. And one more criteria is the motor, the propulsion unit, as well as the power unit, battery. So these three things, weight, power and propulsion, these three plays a major role in designing the engineering to increase the endurance of the drones. Not only drones, any flying system. So any flying system depends upon these three parameters. One is aerodynamics, one is propulsion, and one is energy source. For example, if you take an aircraft, the energy source is the engine with the fuel. So there, the only difference between UAV systems and this aircraft is, in aircrafts you will continuously have a reduced load, because as the fuel is getting consumed, the weight is automatically decreasing. But here in the drones, it is not like that the scenario. You have a fixed battery. By discharging the battery or charging the battery, there is no change in the weight. The weight is fixed. So you have to consider the weight as a fixed. But whereas in aircrafts, the fuel slowly drops down and finally you reach the destination, you will have only 10 or 15% of the fuel. So your weight is dropping and automatically you are gaining the advantage. Okay, so that is the system. So here, talking, we are a startup company, started in 2021, and for the past 2 years, we were in R&D, developing the drones, how to increase their endurance and how to customize the drones and how to indigenously manufacture the drones. So we have our own R&D units. So we do a lot of research in increasing the endurance and doing the slide change. So we make various R&D activities to create drone solutions. So according to the requirements of the customer. So if a customer comes to us, we give the requirements, we make the drone according to it, and we have a test flight for it. And if suppose drone wants a certification from Government of India, that also we provide. So what are the engineering things involved and what are the challenges we are facing right now, that I want to just bring into your point, so that in future, suppose if you become a drone engineer, then you can consider those, keeping those points in the mind, you can design your own drone according to the requirements, whatever you want. So now all the drones are not the same. You can modify the drone according to your requirements. Simple example I will tell you. So for example, if you go to Ashok Leyland company, so if you want to buy a lorry or a bus, so you will have just go and see. You will have only the chassis and a driver unit. Except that you will not get anything else. Just they will ask you what is the capacity, 20-ton capacity, 40-ton capacity, or 60-ton capacity. So like that. So if you go and see, you will get delivered only the chassis unit along the driver unit. Just driving will have the seat in order to drive the entire unit. And how you are going to convert the body, how you are converting that automobile, whether you want it like a bus, whether you want it like a lorry, or whether you want it like another, some kind of any other system, the body construction is depending upon you. So if you tell another vendor that I want this kind of body, then they will make the body for that whatever the capability it can deliver. 40-ton, they will make the 40-ton body system according to that. So it's the same way, we have a drone. So how to convert it according to the requirement lies in our hands. That is the engineering we have to do. Okay, next. So our mission, so simple. It's to create drone technology that inspires, empowers, advances. We are driven by the belief that sky is not the limit. So we have a lot of opportunities. So drone technologies are coming. So still it requires more development. So sky is the limit. So innovation, integrity, customer centricity and teamwork are the major. In any company, these are the major things. Next. Then what are our products? So these all are our products. So we are into surveillance drones, weather drone system, cargo drone, ground control stations, and as well as we are into electronic warfare, drone jammers and mobile phone jammers. So for example, if you see, so unmanned aerial systems. So unmanned aerial systems include this drones. For example, here this is a VTOL drone. So this is a VTOL drone which can take off vertically and go. So it doesn't require any runway. It's a fixed wing drone. You know the drones are two types. So these are multi-rotor drones and those are fixed wing drones. So fixed wing drones generally requires a runway. Okay, but in order to avoid the runway requirements, what we will do is we will provide a vertical takeoff and landing system. So once it takes off vertically, automatically the forward propulsion unit comes into picture. This is the forward propulsion unit. So it's a pusher type configuration. So once it goes to sufficient altitude, automatically the pusher motor starts and pushes forward and wing starts generating the lift. Then automatically these four motors will be switched off. Okay. So this is the program we have to tune it. Okay. Once when you are losing the lift, automatically these four motors starts running and they will generate the sufficient lift. So this is the program we have to feed to the flight controller. And similarly here, this is a ground control station. So what is a ground control station? For example, in case of fixed wing drones are meant for very long range applications, more than 10 kilometers. So multi-rotor drones around 10 to 15 kilometers is a good range for them. So if you want to send beyond 15 kilometers, 20, 30, 50, even 100, more than 100 also, some drones are available. So in that cases, whatever the generally you see the pilots operating the handheld remote control, handheld ground station is not sufficient. Okay, so you need to have a bigger unit. So what is a bigger unit means? It should have a very big antennas and it should be able to communicate to the drone in a longer distances. So you need a lot of RF power, radio frequency power unit. So in order to increase the radio frequency power, so we need a huge system. This is the ground control station, and you can see the joysticks here. Two joysticks are there. So those will have independent channels. Using this, it will have a RF amplifier inside it. So it will generate a lot of RF power so that you can communicate to the drone beyond 15 kilometers. So for example, this ground control station, this is whatever we develop, it can communicate to the drone up to 50 kilometers. You can have a video feedback from the drone as well as video, health characteristics of the drone. What is the health characteristics? For example, what is at what RPM the engine is running or motors are running, and what is the voltage and power consumption levels, and how the drone is behaving, at what altitude it is moving, and what is the forward velocity. All those telemetry information you can get in one screen, and whatever the payload. For example, in the payload you will have a different various kind of cameras, so that whatever the video given by the camera appears in another screen. So you will have two screens and a joyful controlling. You will have a very joyful control. Instead of feeling problem with a handheld remote, you can comfortably drive like an aircraft. Okay, so that is the comfortness of this ground station. And this is the tethered drone. What is a tethered drone? Tethered drone in the sense, generally the drones are powered by batteries. Okay, so instead of providing batteries, what do we do is, here the drone is there. So this drone is powered from this ground control station. This is ground control station as well as ground power unit. So through a tether, a lightweight tether will be there. Tether nothing but a cable. So a cable will be there, 100 meters cable. So that cable will supply the power from this ground unit to this drone, and the drone will constantly hover at a place. At a place it can hover, and its endurance is 6 hours. And more than 6 hours also it is possible. Okay, so what is the application of this drone? So tether drone, it stays at one location. It cannot move because it is connected to the ground control station via tether. Okay, via cable. So it can stay at one location. It is just, you assume that in the security areas, you have a tall post. So you have a tall post where one security guard will be seeing the entire area. So it's just a replacement for that security guard. So if you keep this drone hovering at one place for 6 hours, the camera which is the drone is having, it can see up to 1.5 kilometers. Right now it is 1.5 kilometers. You can still increase the range of the camera. You want A bigger camera? Yes, we have 5 kilometers range. You can see up to 5 kilometers range. Number plate detection, human tracking, it's a human motion tracking, vehicle motion tracking, and what is the vehicle number plate, all those things can be recorded. So that entire feed of the video, 4K quality video, comes to this ground control station and it can be recorded here. So there is a hard disk and computer built into this system. So it is a ground power unit as well as ground control unit, ground control station. So entire video will be recorded for 6 hours in this system. Okay, so it is just like a tall post replacement. Where its application, for example, a politician is conducting a huge meeting, so you want to monitor the security. So this drone is better suitable. So you just launch 4 drones, you can cover entire area. Not only that area, up to 5 kilometers, you can watch what is happening very clearly. So that is the application of this drone. And this is a logistics drone, or a cargo drone. So this is Dhruvika cargo drone, which we designed. Up to 50 kg payload it can carry for 10 kilometers. Okay, it has endurance about 30 minutes, 25 to 30 minutes based on the payload. So maximum payload capacity is 50 kg. It is a very huge drone. It will be very huge. The span will be around 4 meters, tip to tip. So very huge drone. And we have drone jammers. For example, some enemy countries sending their drones to monitor what is happening in our borders. So you need to stop their drones. Okay. So if you kill the drone, if you just release the bullets and kill the drones, what happens? The drone may fall into their territory, or whatever the feed they collected, everything will be destroyed. So instead of that, what drone communicates via radio frequency. You just block that radio frequency, then automatically drone doesn't know where to go and how to go. So it will come into your territory. Just after some time, when the battery is over, it will fall down. So when it is fall down, you can collect all the memory cards and everything safely, and you can see what they have, what the information they collected. Instead of killing the drone, it is neutralizing the drone. Okay, so without damaging much, you are neutralizing, and as well as you are monitoring what information the enemy is collected from us. So that is drone system. And these drone system, anti-drone systems, their power is dependent upon how much big amplifiers we are using. So they are ranging from 500 meters to up to 5 kilometers. So various power systems we need. It is a huge system, anti-drone systems, and as well as mobile phone jammers. For example, when Delhi police, they asked us. So in the prisons, illegally the prisoners are using the mobile phones. So to stop them, they need jammers. So we made some jammers, and some terrestrials are going with the Delhi police, so to provide jammers. So once you install the jammer in this area, all 2G, 3G, 4G, how many number of channels are there? So those channels will be blocked, and you cannot do any phone communication. Automatically your phone communication will be stopped. So that is one more electronic kind of warfare. So now, what is our advantage? So our advantage is mainly R&D. So we do a lot of R&D to make the drone according to the client requirement. So we have a strong technical team for R&D to provide customized drone solutions tailored to specific requirements, products, powered by latest advancements in technology and providing a competitive edge. So you give your requirements, you come to us, give your requirements, and we will make a drone according to your requirements. So that drone only fits to you. Nobody can use that drone. Okay, it is only fits to your requirement, so that it works very efficiently. Don't buy some drone which is available in the market and just compromise with its features. No, it's not good. You just give the requirement. Of course, somewhat it is expensive because we do R&D, we make the drone for you. Even though it is expensive, but it is reliable and permanent solution. Okay. So we have another advantage. We do drones entirely in Chennai. Okay. So till now we are doing the drone in Chennai. If some facility is not available, we'll go up to Bangalore. That's all. So we are not crossing these two areas. Chennai and Bangalore are sufficient. Everything you can make yourself. No need to get anywhere. And compared to R&D activities and the drones available for this scenario, if you compare with the foreign drones, so our drones are somewhat economical compared to the parameters you are expecting. So same parameters, if you expect and ask a foreign vendor what is the cost of the drone, then definitely the drone costs more than us. Definitely you will challenge and say it will cost more than us. So what is the advantage you will get ultimately is a customizable drone and in-house fabricated drone with warranty and everything, and 24 hours support, 365 days support will provide you. So those are the advantages we are getting. So this is our R&D unit. We have our own R&D unit. So where we do a lot of studies. First we perform studies in terms of drone. Actually, if you say drone, 50% is electronics and 50% is mechanical. So electronics is very, very important for the drone. And 50% relates to the structure, how you can make it as a lightweight. So that is utmost important. So electronics and as well as the mechanical systems has both equal importance. You cannot neglect anything in kind of, not only drone, in kind of aircraft or in kind of, if you take the scenario of a fighter aircraft, electronics is more important rather than the mechanical systems. So how much you can hide from the enemy's radar, how much better sensors, how much best technology you have. So electronics plays nowadays a major role. So both sides, so we have R&D unit for the electronics as well as the embedded systems, and automatically the mechanical systems. So we have a mechanical R&D unit. So we do ideation. First our team will discuss what is the idea, how to produce it. Then we will perform a lot of iterations, group discussions will go on. We will argue with each other. Then this is the best, this is the best. Then we will see various methodologies in which way we can achieve the best performance. Then we will start with the prototype. Then we will perform a lot of trials. Here and there, we'll go out of the city because we cannot fly the drone in the city. If you want to send the drone within 2 kilometers, no, it's not possible in Chennai. I have to cross 70 kilometers and find a open area, safe area where no houses are there. So that is the risk we have to take, and we have to fly, test it for continuously 1 month. Then only we can give it to the customer. Okay, simply we cannot make a drone and directly put in the hands of the customer. So we have to do a lot of test runs. Stage 1 test runs we'll do in our area, in our site itself, where proper hovering is happening, proper taking off, proper you are calling back, drone is coming back. Once stage 1 trials are over, stage 2 trials. Stage 2 trials, you have to send the drone. What is the range you are giving? Beyond that range, you have to send the drone. You have to check its performance, whether it is going properly and coming back to you properly or not. So that much R&D is involved. We have to do a lot of R&D. So now, yesterday, you might have seen many people discussed. So we should make the technology ourselves. Everything should happen, make in India. Now the problem is, all of a sudden, you cannot make everything in India. Okay. All of a sudden, okay, the initiative is started, very good by the government of India, but everything I want is right now from Make in India, not possible. And at the same time, if you start making in India, now your products will be very, very expensive. Maybe after 10 years, we may reach to a stage where China is competing with us. So suddenly, all of a sudden, if you want, it's not possible. So what are the challenges we are facing? Scarcity of indigenous electronics. You know, India is very top in aerospace systems, but still we are weak in electronics. For example, you take your mobiles, where your mobiles are manufactured. Only 2 or 3 companies are there right now in India. So where all the mobiles are manufactured, everybody is made in China. No other option. Not only India, entire world is depending upon China. So slowly we have to come out of this. Slowly, all of a sudden it is not possible. Slowly we have to come out of this. Then BLDC motors technology. Still BLDC motor technology, China is the top. Nobody can beat China. So BLDC motors are used in all the drones. Okay, but recently in the last 2 years, some 5 to 6 companies have started in India producing our own motors. They are growing, but still a lot of development is required. Okay? And battery technology. You might have seen in the last 6 months, lithium reserves are found in India, in Jammu Kashmir region. You might have seen in the news. So now only we came to know that there are lithium reserves in Jammu Kashmir, which is sufficient enough to power our automobile sector as well as drone sector. Okay, so now we have found the lithium resources in India. So we have to extract it, we have to mine them, we have to purify them, we have to start using them for the battery. Still it requires 2 to 5 years. Okay, till that time we are dependent. And composite structures. Okay, composite structures right now India is progressing. Okay, well and good. So a lot of companies are involved. This is okay, sufficient. Composite structures, we are not facing that much problem. Okay. And suppose I told you. So make in India is suddenly not possible. It requires some time. And at the same time, if you stop all the imports from China, who are the ultimate sufferers? We are the ultimate sufferers. Okay. Suddenly it is not possible. Suddenly you start a company, start producing the products within 1 year. It's not possible for any company. So we have to slowly stop depending on China. It is a slow process, not a sudden, all of a sudden. That too in India, all of a sudden it is not possible. So slowly we have to come out of this situation. Till that, we need to import the products. So to import the products, what is the main ultimate problem is customs. We need to pay the customs, which is increasing the drone cost. So technology wise, what are the challenges? So flight controller boards, which are the heart of the drone. So they require a lot of embedded engineering, electronics into the microchips. The chips which are base source of any automobile system or flight control systems, aircraft systems, everywhere the chips are the major. And the chips are 90% of the chips are manufactured in Taiwan. So we need to import it. Suppose if Taiwan stops producing this, I think this also came into the news. So during the Corona time, the chips production has been reduced by Taiwan, and till 2024 starting quarter of the till March 2024, that impact was there on automobile industry throughout the world. So because nowadays you can see entire electronics, the dashboard system is in the cars fully electronics. You have a microchip, so where microchip takes over the entire controls. If you take luxury cars, still it is far beyond. You have a tire pressure sensor, you have engine manifold pressure unit, engine temperature monitoring unit, RPM unit, and you have various temperature control, humidity control systems. Everything is electronics, luxury cars you see. And you need not to do anything. Everything microchip will take care. Suppose if microchip production is stopped, then that's all. Automobile cannot be produced. Simply you cannot produce tires and wheels and chassis and you cannot give it to your customer. Customer needs comfort. That's what he is paying for. So the comfort comes from again electronics. So all these factors are involved. So again battery technology, that's what I discussed. So slowly we have to start coming out of dependency. So we need to make our own technology. A lot of youth like you should complete your degrees and start your own resources. So your own company, you should become the entrepreneurs and you should start a company and see what are the problems. First you study the market. Before starting any company, what you have to do is you have to study the market. You work in somewhere for 1 year, 2 years, then you will have a knowledge. What is happening in the market? Where I can excel, where I can go forward in a very less time. So that market study is very important. You can see a lot of startups are coming in India. 95% of them are not sustaining because the problem of funding and not having proper knowledge. You can start a company very easily, but you cannot run a company for years without any income. Okay, you ultimately need to give some income for the employees who are working in your company. So that is one more important. So you have to know what is happening in the market. Market study is very important. Then composite structures, of course, I told composite structures. We are as of now we are good. Still, the technology is developing in India. We can right now most of the companies are making their own structures. Still, we need lightweight, very lightweight, and at the same time strength. You should not compromise for the strength. In aircraft industry, what is the ultimate goal is strength to weight ratio. How much good you have strength to weight ratio, that much efficient is your structure. Okay. So if you consider automobile system, weight is somewhat compromised, but in aircraft industry or drone industry, you need ultimately strength to weight ratio. Very good strength to weight. You need to have a lot of strength in your structure, and at the same time it should be lightweight. Okay. So the best things are composites. Still, a lot of researchers going on natural fibers and some other choppers based fibers, composite fibers. So still, okay, if better and better systems are evolved, we can improve our endurance more and more. So till now what we are facing problem is still that we are dependent. We need to import the products. Suddenly, all of a sudden, indigenization is not possible. All of a sudden, everything, Rome is not built in a day. Okay, so everything is Not possible all of a sudden. Slowly we have to come out of the situation. At the same time, we cannot say no, we cannot come out. No, we have to come out. But which cannot happen in rapid, which happens in a slow. Slow growth is always a stable growth. Rapidly happening is unstable. Suppose if you see any shooting out phenomena, definitely at what rate it has shooted out, at the same rate it will fall down. So stability is very important. So slowly we have to start coming out of the depending situation, and we have to make our own technology. Ultimately, we need our own technology. Then only we can survive in this world. Never go and ask the enemy, I need something. So he may give you a wrong product also. Okay. So slowly, definitely we need to come out of this situation, but take some time. And what are the outcomes? So for example, if you can have your own technology, even the government of India is also insisting, as of now, if you have more than 55% of the components made in India, it's enough for us. That is the right now policy they kept. Because they also know, all of a sudden, it's not possible to make 100% indigenization. Okay. So more than 55% is the criteria right now they kept for indigenous components. So suppose if we have 100% indigenous components, everything made in India, what is the advantage we are going to get? So the reduction in drone prices, definitely 50% of the drone prices will come down, and you will have a better technology in your hands for a lesser price. Okay, and a reduction in after sales support. So you are also paid for, suppose you are buying the drone, simply the company is not giving you 1 year warranty. For the 1 year warranty also, automatically all the companies are charging you, not only drone companies, even for electronics, even for various other components also, everything, the 1 year charges are also automatically considered. So all these things will come down, and also lot of opportunity will be there for the youth. Okay, so you will get a lot of job opportunity. Once indigenous requires lot of young engineers, lot of skillful engineers. Okay, so once we have our own technology, lot of opportunities will be open to you. Okay, you need not to search for government jobs. Private jobs will ask you to come and join with a good package. And at the same time, you should be that much skillful. See, studying is one side scenario and applying is other side scenario. There is a vast difference between theory and application. Once you study it, unless you don't go to lab and you don't do the experiment, you will not understand the basic principle of that. So labs are 50% equal important to the theory. So whatever you are learning, definitely you practically face the situation. For example, you are studying the strain is this much is happening when you are loading a simply supported beam or a cantilever beam. Go to your lab, put a strain gauge. Just make each load what is the strain happening, you note down. Then only you will practically come to see where is the deformation is happening, where is the bending is happening. So you experience it. When you experience only, you can become a readily employable engineer. Only reading the books will not make you ready for the job. That's what everyone says. Companies are there, engineers are there, but companies are not getting skillful engineers. Those who are directly given job opportunity. No, it's not possible, because 50% of practicals are very, very important compared to the theory. Then only you will have the practical knowledge. You have to go and practice it, whatever you learn. Otherwise, you cannot execute it, you cannot apply it. So what the ultimate things are required is companies should come and partner with the education institutions, and both sides they will get, company will get an advantage. Small works can be given to the students, can be done by them, and at the same time student community also will get into benefits. Okay, so because colleges cannot afford much more costlier machinery, it's not possible by colleges, academic institutions. So institute industry interaction is very important. Institute should go and approach the industries to provide some internships, to provide some kind of workshops to the students. Then only student can have the much benefit. Practical scenario is very, very important. So strategic partnership plays very much vital role in indigenization. So if you want our own technology, what is the ultimate thing is partnerships. and innovation in electronics, motor, battery composite. Automatically, once you have a partnership, once industry is coming to the academic institutions, then automatically you will get skillful engineers. When we have a skillful engineers, all the technology will be in our hands. Okay. And imports and exports, we have to make some certain rules for importing as well as exporting the products. Okay. So because sometimes it will be misused, so those scenarios also we need to stop them. So this is my conclusion for today's presentation, and thank you for giving me this opportunity.
Thank you, sir, for your information. Thank you, sir, for your informative presentation. Now, I request Organizing Secretary of the seminar, R.K. Muthuraman, sir, to honor the Ramakrishna sir.
Presentation abilities. One second. Sir, point regularly. Open.
Thank you. Thank you. So next section is going to be delivered by Dr. J. Ashok Babu, sir, Chief Finance Aviation Analyst, Pulilan Aerospace Technologies Private Limited. He is going to deliver the topic under Aviation in India, Challenges Ahead. So with this note, I request Ashok Babu, sir, to deliver the topic. Please, sir.
Yeah, bro. Bro? Yeah, come here. Okay, sir. Yes, sir. Point nice. Okay, sir. Okay, sir. Okay, right. Forward. Okay, sir. This is the next, sir. This is the back. Okay, okay. Pointers. Pointers. So, live.
Very good morning, all. Good morning. Thank you. First, I'd like to thank you, HOD, for providing a platform for sharing my experience. And also, my special thanks to Institution of Engineers, Tamil Nadu Center, as well as the local center, Tanjavur. And my very, very special thanks to your Vice Chancellor, because I done my PhD from College of Engineering. He was a professor there. Okay, thank you. So today I'm going to share what are the experience and what are the challenges, particularly for the aviation industry. I think all are aerospace or aeronautical. Yeah, good. See here, there is a lot of challenges are there, and during your 4 years curriculum, we have given only a basic information. Okay. What you have to do after that, you have to gain a knowledge or a skill through your internship and industrial experience. That I'm going to share now. So another 30 to 40 minutes, I'm going to share what are the challenges are there and what are the key trends are there, particularly for the students community. Okay, please try to take one or two important areas. So another 30 minutes, this is my agenda. What I'm going to say that what is the aviation? Because most of the students, though, they are not aware exactly what is the aviation, what is exactly aeronautical, aerospace. There is a small difference of that actually I'm going to share. And next is what is the characteristics of aviation industry. See, when you go to the aviation industry, we have some unique characteristics, which is totally different from other industries. And next, I'm going to share what are the career options are available in India. And next is what is the IATA forecast and what is the passenger handle, particularly during your 2024. And very importantly, the various design and manufacturing operations and management challenges, very particularly the aviation industry. Okay, and what are the key trends? Okay, I think all of you are aware that because you are all doing a second year and third year and final year student, you know that what is exactly aviation. Before I start with the aviation in India, I would like to share what is exactly aviation. Because whenever you go for the interview, any airlines or MRO company, they ask this question: what is exactly aviation? What do you study? What is the contribution you can give to the aviation industry? So, you see, when talking about the aviation, it is the activity of flying an aircraft, designing, manufacturing, maintenance, operations, including aviation management. All this comes under the one umbrella is called as the aviation. Please try to understand. So here, what are the areas you have to think about? The flying of aircraft, designing of the aircraft, manufacturing of aircraft, operations of the aircraft, maintenance of the aircraft. I think all of you know why do you want to maintain the aircraft? Because you want to maintain the aircraft in a airworthiness condition. What is the airworthiness condition? So that's a very important area for the aeronautical or aerospace engineers. Okay. So we're talking about we'll move to the next area called aviation in India. We're talking about aviation. India has emerged as the third largest domestic aviation in the market. All of you are happy about it. After US and China, we are in the third position in the domestic market, not the international market. I think we are all proud of that because we are the third in this global scenario. And you know what exactly undergoing the various transformation. We'll see that what are the transformations. See, when you look at this industry, we have a certain characteristics. One is a very specific technology. So when you design an aircraft or manufacturing aircraft or operations aircraft or maintenance, even including a management, we require a very, very high standard specific technology. Please try to understand. You are totally different from other branches. When you study aeronautical, design is entirely different, manufacturing is different, maintenance is different, and management concept is different. Because our standards are very, very high. Yesterday they all pointed out because our area which we focus on the quality aspect. When you design aircraft or manufacturing aircraft operation, everywhere is required quality. Because yesterday also I gave an example, even if a small element change in the aeronautical or aerospace, you see the failure immediately. You understand? So here what is required? You require a very high specific technology. And here now we are not going for the mass production. So our productions are limited. To take a Boeing and Airbus, their production is very limited. And next is very important, the long-term development. It is not like your two-wheeler or a four-wheeler. You can keep on changing your design aspect. It's a long-term. Suppose you design an aircraft today, it should serve minimum 30 years. It should serve how many years? 30 minutes. You can't keep on changing it. Okay, it's a very long-term development, and lot of governmental interventions are there. I think all of you know that 2016, Government of India has made a policy called National Civil Aviation Policy 2016. I think all of you have that. Please go through that policy, because you are an aeronautical student. You should know your own policy. What are the areas the policies are focused? What kind of incentives are given for the design area, the manufacturing area, maintenance and operation? Okay, please all of you go through your National Civil Aviation Policy 2016. Okay, and very important that international cooperations are required. So these are the characteristics of the aviation industry. Okay, it is totally different from other industries. Okay. And the career point of view, I would like to, because all the students are here, I like to focus on the career. We're talking the career is a very dynamic and promising path. Please take a note that it's a very promising pathway for individual passionate about the aviation industry. I think all of you are interested to join aviation industry, no? Yes or no? Either you select a design area or manufacturing area or operations area or maintenance, or some of the guys you can go abroad and do your management. Anybody is interested to go for abroad for management studies, because a lot of opportunities are there at transportation. So once you, with your BTech aeronautical MS in air transportation, you can join either airlines or airport industry. And those are interested in design, you can do a gate and then qualify and get into IIT. Okay, so a lot of options are there. You'll see that. Okay, now why it is happening? Because you know that this industry is, the aviation market is booming. I think all of you know that. Your statistics given by IATA as well as the Airport Authority of India. Okay, and then increasing air travel. See, if you look at air travel for the past 10 years, if you go through the Airport Authority of India website or a DGCA website, you can see the delta increments are going up. One is the problem we have come across in the pandemic. Otherwise, what actually happened every year, the passenger as well as your cargo, there is a delta increments happening. So here we have a various career. One is design engineers, manufacturing engineers, maintenance engineers, pilots and cabin crew, and air traffic control. Every year or alternate year, you can see the Airport Authority of India is giving a 400 plus air traffic controllers. Those are interested, you can take up and you can go in for your ATC also. Now, I would like to share this IATA forecast because we have come across number of crises, oil crisis, Iran war crisis, and then the latest 2020 is the pandemic. You can see that the industry, what actually happened. Okay. So these are the various crises that happened, oil crisis, Iran war crisis. Everywhere you see that there is a number of passengers handled in different airports are reduced, declined. But the highest decline happened during COVID. During the COVID, what exactly happened? Nearly about 35 to 65% is decline. That's the highest. I think all of you have witnessed also, no? During the COVID. So most of the company, you can say that they have reduced the manpower. The airlines are shut down. Maintenance also shut down. All this have happened during the COVID. But this industry, nobody can stop. Nobody can stop. Now, as one more forecast, I would like to share. You see here, RPK. Any idea about revenue passenger kilometer? What is that? Revenue passenger kilometer in terms of trillion per year from 2010 to 2024. The 2020, the global scenario is decline. But during the 2020, the IATA is estimated 2024 again will come back. That is estimated which year? 2020. They estimated that 2024 again will come back. It actually happened. I would like to share. We don't want to do a lot of analysis. A simple statistics is give the indication. You see here, the passengers handle at the airports in India. So initially start from 2014. So one is the blue color, your domestic, and this black is your international. Every year you see here in India, what is the increase? This one graph is indicating that aviation is good. And very particularly what happened 2021 dropped, 2022 again coming back, and 2024 you can see that it is coming back to the norm. So this one indication, it indicates that India is good. And we are all proud to say that we are in the third in the domestic market after US and China. Is it clear? So this present scenario, you are all the students, you are getting a lot of opportunities provided by your universities. After that you get into internship and try to get a job so that another 30 years you can enjoy this aviation industry. Okay. Now, one more forecast I would like to share. In 2047, what is that? In 2047. Why you have selected 2047? Any idea? After 100 years? Yeah? We have selected that particular year, thanks to 2047. Our air traffic passenger traffic is going to rise from 376 million to 3 billion by 2047. Now that is our estimate. So the population goes to 3 to 3.5 billion, and if you attract each pack members, that is the one passenger or one person per year per trip. You think about how many airports are required, how many aircrafts are required, how many members are required to work in this aviation industry. Is it? It is going to happen. All this is going to happen, everything in your hand. Because they are all old people. You are the young generation. You can witness in 2024, this is going to happen. Even if it is going to happen 0.7% or percentage, still our aviation will be good. Okay. So this statistics very amazing. Okay. And cargo also. Even during a pandemic also, cargo industry also, they are not gained any loss. Because they are carried some other equipment, there is no loss. Okay. And also our target is near about 10 million metric ton by 2030. So both the passenger side as well as the cargo side, there are a lot of challenges are there. All the challenges, my dear student, you try to understand, you take up only one of this area and try to go for any innovative ideas. Okay. Now, if you look at the airlines business models, their job is to attract the customers. Okay. And if you take India, every members, even if you ask the children around 5 to 10 years, they are also allowed to. But there are certain qualities that are required. Can we say what is that? Most affordable, cleaner, secure, and secure air travel. I think all of you agree, no? If you provide, suppose you are the airlines businessman, you provide affordable, cleaner, safer, and secure air travel, we can attract the passengers. So all this aviation community, including the students community, you have to work and provide exactly affordable, cleaner, safer, secure air travel. And also it's very important, you have to simplify. You have to simplify the task. This is very, very important. You should not make a very complex one. Suppose somebody is interested to fly, for example, next week, Monday, Chennai to Delhi, you have to minimize the procedures. And also, the industry should focus on reducing the cost. Very important. And after this pandemic, each and every rupees, it is very important for the businessman. So first the focus is reducing the cost. That's the most important. For that, you can think about the cost optimization. What is that? Cost optimization. Next is the asset optimization. Very important for the airline business. Asset optimization. Suppose you have a fleet size is 7 aircraft. All the 7 aircraft should be in airworthiness condition. First, and you should not ground for that. So every minute is going to generate a revenue. So we required a manpower to calculate and identify the airborne asset optimization. Okay, and then very important, the passengers experience. Say in the 1980s and 90s, aviation industry is technology driven. But today is not a technology driven, my dear students, it is all customer driven. So customer should feel comfort. Then only you go to the next time the same airlines. Then next time you take the same aircraft. Okay, so it is all, what is exactly? It is the customer driven, not the technology driven. So, my dear students, there are a lot of challenges are there. One is cost. Another is the optimization, asset optimization. And third is the passengers experience. So, in fact, in India, we have various shareholders, DGCA. I think all of you know what is the DGCA? Okay, that is the regulatory authority, and next is the Airport Authority of India, airlines, manufacturers, as well as MRO. We all just put together and try to give a solution to this industry. So the last, what actually happened, 2016, we have come out with the National Civil Aviation Policy. Again, my dear student, please go through the 2016 policy. And 2047 also we have made a plan now. Okay, that also please go to that. When you go for the interview, they may ask a question, what are the aviation policy? You are all guys from the aeronautical department. Okay, please go to that. Now, let me go focus on the challenges. I already told that whether aircraft or airlines or airport authority, everywhere we are not talking about the technology driven, we are all talking about the customer driven. So, our most important goal or objective is to satisfy the customer. So, customer expectation. I think all of you know that. See, when you're talking about the customer's expectation, 1950s different, 60s different, 1990s different. So, when I was traveling in 1990s, I remember that we had tried to find out the ticket or airline. But today, customers know, they just look into the various aspects. One is the airport, which airport is comfortable, which aircraft is comfortable, which airlines is comfortable, and which airlines give the least number, all these things. So the customer expectations are increased. So whether you are the design platform or a manufacturing platform or operations or maintenance or management, your focus should be customer driven and customer expectation. For that, you will think about two important areas, product development. Now you can just go through the scenario of the aircraft design. Okay, since 1950 to today, a lot of changes are happening, all based on the customer expectation. And also we are day by day we are improving the service quality. You go to airlines, the service qualities are improved and also measured. And airport, you go to airport. Which is the best airport in India? Which is the best #1 airport in India? No, based on your experience, which airport? Bombay. One is Bombay.
GI, sir. Hyderabad.
Hyderabad. You're from Hyderabad?
Yeah.
Oh, okay. Then any other? Okay. So based on the various ranking pattern, the Delhi airport is number 1, and number 2 is the Bombay, and then comes to the Hyderabad. All of you go through this some statistics. Okay. And very important, the supply chain. So today there are a lot of opportunities are there. After the BTech, you know what you have to do, you have to write your GATE exam, qualify, get into IIT. Otherwise, you can go abroad and do your masters in the air transportation. Okay. So a lot of opportunities are there. Don't listen to the external members, because those people will say that only the artificial intelligence data science only will help. Not like that. You are taken as a core area. top also. This core area. What you have to do, you can select the tools. You can select artificial intelligence or machine learning. Apply the skill in your core. You will get a better chance. Okay. So, and then finally, I am going to land with the sustainability. That's important. Okay. Now, I'd like to share very important challenges like design, manufacturing challenges, operation challenges, maintenance challenges, and very important, we are talking about end of life recycling challenges. So we cannot, after 30 years, no, we cannot dump the aircraft. We have to recycle. So everywhere the cost is there. So as engineers, we have to find out the solution for it. Okay, that I'm going to share another 10 minutes. So we're talking about the design. I think all of you know the design in 1950 is different, 70 is different, 2000 is different, 2020 is different. Here the design should be focused on customer. So you should get a customer feedback and translate your design. For that we have a number of tools are there, you can do that. So the new design aircraft focus on the passenger comfort. Can you share what are the passenger comfort in our aircraft? You are the design engineers. What are the passengers are expecting and comfort? What are the areas? Anyone? Your leg size, seat comfort, all these things. No, they're all the comfort. See, somebody is flying from Chennai to Dubai or Chennai to US for a journey. What is their expectation? They want to enjoy another 10 to 15 hours. How many hours? 10 to 15 hours now. They won't have any. Okay, their comfort should be very high. Better than other people. So, very important, the new aircraft design focus on the passenger comfort, and very importantly, I'm talking about the cost. Whatever the engine you're designing should have a fuel efficiency. That's very important. No compromise. Otherwise, the airlines cannot sustain. And I think all of you know that we should go for a lightweight composite material, and very advanced aerodynamic concepts are required to satisfy 2030 or 2047 vision. Okay. So, and also we can think about going for the larger windows, improved cabin pressure. These all the things are required. Aircraft design. So, a lot of challenges are there. Okay. Now, we're talking about the design challenges. Suppose somebody is interested about our design area. You can start with the various areas. One is the conceptual design. So when you go through that papers, no, you say that the conceptual design, at least minimum 2 years experience are required. So after the BTech, no, you can think about the conceptual design. Somebody may be interested about design, modeling. So try to learn the various softwares are available. Your CATIA, NSCAD is there. Okay, there are so many softwares are available. Try to take at least 1 or 2 software. Try to learn modeling. Or somebody is interested about analysis, like a structural analysis, CFD, you can think about Order, or you can think about the ANSYS. Okay, so all these areas, what is required? You require a software area. Software skills are required. So, my dear student, you will get a very nice job if you have knowledge about strength of material, finite element analysis with the software experience. Don't compare with the IT or don't compare with other things. You have a job, sir. Please, all of you, again go back and study your strength of material, finite element, and take any one modeling, another answer. Definitely 100% you will get it. Suppose you are interested in aerodynamics, take a CFD. What both software area as well as experimental area. We have a facility, internals are there, you can utilize it. Okay, if you have knowledge on software and experimental side, 100% I assure you will get it. Only thing you have to work on. And here the university is providing a good ambience, good faculties are there. Utilize and try to put a pressure at least 2 hours per day. Okay, so these are the design challenges. So manufacturing challenges, a lot of challenges are there. Now, a lot of things are coming up called additive manufacturing. What is that? Additive. Anybody can explain what is additive manufacturing? Today, all this aviation industry talking about additive manufacturing. What is the advantage? Anyone? What is the difference between additive manufacturing and your conventional manufacturing? Anyone can? Yeah, anyone, please. Okay, but what is the basic difference between additive and conventional manufacturing? Yeah, time is okay, but what is exactly the process difference? Yeah, very good, excellent. Why not? Additive means layer by layer you are adding, yeah? Excellent. So additive is the adding process, it is a removal process. And all of you know that the importance of additive manufacturing in your aeronautical. Please go ahead. So here I will share very important scenario what is happening in India. The manufacturing industry is like the US, France and UK where the labor cost is very high. Please try to understand where the labor cost is very high. Where India labor cost is much lower. So this is the opportunity for all of you try to get. So those who are interested in the manufacturing, you can think about go in terms of the conventional manufacturing or additive manufacturing. 100% you will get a job. So that is the next area. One already discussed about the design area, another is your manufacturing. Okay, next. We are talking about the manufacturing challenges. There are all challenges are there. You are all engineers, no? You know that what are the challenges? One is the production cost. So somebody can work on the production cost. Please reduce the 1% or 2%. That's great. So your innovative ideas kindly put in this area. What is the production cost? And very importantly, the Boeing company as well as the Airbus company and other companies are interested about what? On-time delivery. What is that? On-time delivery. Next is the reduce quality risk. My dear student, the quality risk you have to bring to zero level if you want to sustain. Yesterday, you have come across, no, sir also told them, even a small element fail, entire mission is failed. That is the characteristic of this aviation industry. One small element. You can see that there are so many crises, so many incidents happen. Finally, the conclusion is one small element. Maybe a theme, maybe a joining them, that's all. So we have come to a 99%, only 1% is lagging. So, my dear student, please think about minimizing or zero quality risk and improve the visibility in the production. Next is your prediction, which is going to mix with your artificial intelligence and short time to market, increase supply chain, meet compliance requirement. What do you mean by your meet compliance requirement? In civil aircraft, you have to meet your requirement DGCA. In case of the defense, what is that? Semi-life. What is that? Semi-life. So semi-life is developed a certain requirement and DGCA requirement. So you have to meet. So these are the manufacturing challenges. You have a lot of opportunities in India as well as abroad. And next is very important, the operational. Now the aircraft is designed and manufactured. It will go to the airport. It will go to the airlines. So what are the challenges in operational? That's also very important. So optimizing the aircraft operation maintenance to achieve the optimal fuel save. What is that? Optimal fuel save. So there is a lot of software also developed. So those who are interested, you can work those areas, and after gaining 6 months experience, you will get a job in a private airlines or private airport. Plenty of jobs are there. Okay. And very important, think all of you know that MRO. MRO, maintenance, repair. What is MRO? Maintenance, repair and all. Okay, 95% of the MRO business simply going to other countries. You need not search for any business. Our own aircraft, our 400 fleet aircraft, out of that, 95% is going to other countries. So if you develop a MRO hub, definitely you will get a plenty of opportunity. For that, 2016 National Civil Aviation Policy already drafted. These are all working out. You can see in the 2025 a lot of opportunities in MROs. Now I would like to share here. My dear students, when talking about the maintenance, why you want to do a maintenance? To maintain the aircraft in airworthiness condition. That is our ultimate aim. For that, we have a different type of maintenance. One is the reactive, another is your proactive. What is that? One is your reactive, another is your proactive. See, the reactive concept all happened in 2000. Now we are in the position to go for any reactive. We are all going in terms of proactive. In the proactive also we have two. One is the preventive, another is the predictive. Please try to understand that we have a one is called preventive, another is your predictive. So here, when you order the reactive, it is only a failure base. It's too late for the airlines industry. Then in the preventive, you have age base and condition. So these are the drones, visual inspection, next generation. And very important challenges, you know that reuse, reduce, and recycle. I just developed some concept about the reuse. Then I would like to focus what are the key emerging trends in aviation. One is the sustainable aviation, advanced air mobility, digital transformation. And you should know what is the sustainable aviation and what the Boeing and Airbus is focused. And you should know what is the advanced air mobility. And next is your digital transformation. So you're all in the digital area and trying to develop certain tools for that. And what is the tomorrow's airport? So these are the airport strategy. And these are the sustainable transportation. Finally, very important, since everybody is talking about the artificial intelligence, you can use the artificial intelligence in your aero industry. So these are the areas. One for the aircraft design. For aircraft design, you can utilize the review management, you can use safety, you can use feedback analysis, you can use, and automation area, crew management, fuel optimization area is widely used. So those are interested fuel management, you can take a tool of artificial intelligence, mix, and then definitely you will get a job. That's what the industry is looking. They are not looking a very old concept. They are looking a new concept and a new ideas. So you are all youngsters, no? You can try to develop some new ideas so that you can give a solution to society as well as aviation. Okay. Now, very important, I want to share that according to the airport industry, for the maintenance point of view, predictive maintenance can reduce unplanned maintenance. Please make a note. What is that? Unplanned maintenance. How many percentage? 30%. And increase the aircraft availability 20%. For that, you can use the artificial intelligence tools. Okay. You can see that this is the predictive maintenance using artificial intelligence. So one is the scheduled maintenance, condition-based maintenance, predictive maintenance, corrective. You are going to identify part in advance using your artificial intelligence. And very importantly, somebody can think about going for a digital twins concept for your design area as well as your maintenance area. Here also a lot of job opportunities are there. Okay. Now the time is not permitting. I'm just making a small conclusion. Economy, one. Second is your rising income, and a very good supportive policy. That is the policy after 2016. And intensive competition among the airlines. Indian aviation growth is likely to continue. Okay. Okay. So the one more conclusion, India's commitment to the sustainable growth, supported by the development of the mega future ready airport. So Airport Authority of India, you can see that every year they are going for a green airport, brown airport, or going for a better airport, and also innovation, everything happening in your aviation. And very importantly, I like to share a very important conclusion. It's all possible if we have a industry, institution, intensive intellectual interaction. Because yesterday somebody was asking you what is the point. See, if you miss any one of this element, you cannot develop or derive any strategies. So my conclusion is industry, institution, intensive intellectual interactions are very much necessary to meet the challenges for today or tomorrow or 2040. Thank you.
Close பண்ணிருக்கேன். presentation அவ்வளோ க்ளோஸ் பண்ணி ஷட் டவுன் பண்ணிடுவோம். ஷட் டவுன் பண்ணிடுவோம் சார். ஷட் டவுன்.
Thank you, Dr. Gop, sir, for your deliberate speech. The topic of aviation in India, challenges ahead. So students came to know more about the MRO because most of them from aerospace engineering. So they got some knowledge about MRO, maintenance, repair, and overall. Now it's time to honor our speaker. I request Dr. C. Devamani, Head Aeronautical, Mahindra Engineering College, and the RNC member of this seminar to come over the dais to honor our guest, Dr. J. Ashok. Please, ma'am, please. Thank you, sir. Thank you, ma'am. So there will be a very short break. So because 11 to 10, Dr. Uma Maheshwar from GE Aeronautics is going to join through in online. So everybody are expected to take your refreshments at backstage and join here within 5 to 10 minutes, please. You can go and take your refreshments from that, please.
காப்பி பண்ணுங்க. இல்லை சார் ஒன்றும் பண்ணலாம். Moving for another presentation. Okay, sir.
For us, before us, to support this initiative, especially for last 2 days, it is going great. Thank you, sir, for joining online with us and delivering the sessions. Sir, have good days. You can't hear the videos. You can't hear the audio. Can you see the video? We are all seeing you. Yeah, can you? Okay. Thank you, sir. Thank you, sir. Sir have organized, he had a travel plan and he booked the tickets and all those things. And finally he cancelled all the, like, he couldn't join and it was his personal thing and unfortunately it was bad that we missed it to meet him physically, but next event he will join for sure. Thank you for joining us today, sir. Yes, the session is yours.
Okay, so very good morning to you. So excited that Dr. and the rest of the IEI association has organized this event. What is very commendable is the fact that this has been organized in a rural place. I have a particular interest and passion for all the students like you who are coming from very poor backgrounds, from rural backgrounds. So it is my privilege, really excited to be part of today's session. So we'll do one thing, I will cover my session in maybe 20-25 minutes. And then if you have any questions, we can take for the rest of the time. So I want to tell the upfront that you must be really privileged and take pride to be what you are today on three things. The first and foremost is the chance to work in aerospace. I can tell you in the next few minutes that there is nothing like aerospace. So the chance to work in aerospace engineering is very, very special. It's a privilege. It is not like any other field. So you must be really, really proud for choosing mechanical aerospace engineering. Not that I'm not having any respect for other branches, but aerospace engineering is the most complex field of engineering. So number one, right, the chance to work in aerospace. The chance to be at the point of time in the history of aerospace where we are going to see disruptions. So we are going to see changes around you. So I call this as the Wright brothers. We are exactly at that era where Wright brothers invented the first flight, 121 years. I call this as the Wright brothers movement because there are a lot of changes happening. So I will explain to you that a little bit. So the second thing that you should be really proud of is the chance to be in aerospace engineering at the time when you see a lot of disruptions. And the third and the most important thing is the chance to be an aerospace engineer in India, because India is going to be the third largest market for commercial aerospace, and the largest market for military aerospace already. But we are going to see India driving a lot of growth for the rest of the world. It's the fastest growing aerospace market in the world. Okay, so think about it, right? So you are really at the right place at the right time. So I wanted to always remember these three things: the chance to work in aerospace engineering, the chance to be in aerospace at the time in the history where we are going to see a lot of disruptions, and the third, the chance to be in India being as an aerospace engineer. With that, let me qualify whatever I told, because as I said, it's very, very special to be an aerospace engineer, and I wanted to tell you some things around what I spoke. I don't know if you are able to see my screen. Can you see my screen? Can somebody confirm?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
So the aerospace industry in last 121 years, at every time, there is one thing which has driven the whole industry. For example, when the commercial aerospace started somewhere after World War, World War II, 1950s, 60s, all the way till 1980s, you can say for the next 25 years, it was all about, two things. One, flight safety. It was considered to be the most dangerous mode of transportation. Aerospace, if you fly through a flight, there used to be a lot of accidents. Many people used to fly. So it was considered to be the most dangerous mode of transportation. So now, today, it is the most safest mode of transportation. Actually, the next safest mode of traveling is by walking on the road, but not in India. Okay, so but globally, if you see, the only safest mode of transportation by far near to aerospace is actually traveling on the road, walking on the road. So you can imagine how the whole industry has transformed from being the most dangerous mode of transportation to the most safest mode of transportation. So safety was one of the drivers, and then it was all about fuel emissions, because you want to make the the flight affordable. It used to be very, very expensive, so everybody was working on improving the efficiency. So you can say from 1950s, late 50s, all the way till 1990s, you can say it is all about improving safety and then efficiency. And then later on, it was all about more power, because now you need bigger aircraft as the air transportation become more popular. You now need big aircraft so that you can take many people, which will also improve the cost of travel. But at the same time, you can go for international flights and the cargo and those kind of things. So in the next say 20 years, it was all about more power. And then late 90s, you can say there were regulations as the air transportation became very, very, very popular as compared to the other modes of transportation. Then there were restrictions on noise, noise around airports, and then also emissions. And then later on, as there are, particularly in, from the start of this century, there were many new airports which were built outside US and Europe. The countries like Middle East and other countries like India started growing, and they started building more airports. Now it became very important to really focus on the cost. All right, now if you see that cost of transportation, air transportation, flight is very much comparable to other modes of transportation. For example, you want to come from Chennai to Bangalore, so you can't store in the form of gas because then you need huge containers. So aircraft cannot hold these big tankers. So we need to liquefy hydrogen so that you can store in small volumes. But for that we need to have cryogenic technology. So you have to liquefy hydrogen, and there are inherent dangers of burning hydrogen. Leakage of hydrogen is very dangerous. Any small leakage in the aircraft is going to be catastrophic. And we are talking about really building a whole chemical plant on the aircraft. Think about it. It's not just hydrogen. You need to liquefy hydrogen. You need to store. You need to transport. You cannot have any leakage. And how do you transport? How do you burn hydrogen? If you burn, can you burn hydrogen without having any problem with the combustion technology? So it looks great that we can simply replace the fuels with hydrogen, but there are lots of challenges. Okay, so that, but remember, 65% of emission reduction happen by simply changing the fuel, either the sustainable aviation fuel, the alternate fuels that I talked about, or in the long term hydrogen. Okay, so that's 65%. The remaining percent, 10 odd % will come from technology improvements. On the aircraft, let's say you go for more composites, more blended wings, aircraft technology. We can also use digital technology. For example, before the aircraft lands onto the airport, in busy airports, the aircraft waits for getting the slot to land, because these are very, very busy airports. So in the process, aircraft is hovering around or waiting, and in the process we emit a lot of emissions. So the solution is, can we automate, can we reduce the waiting time through digital technology so that aircraft doesn't have to wait over around the airport and reduce the emissions. Or for example, you can have a flight path optimized to reduce the emissions. Okay, so that's the way you can get maybe 10 or plus. The remaining improvements will be around putting more restrictions. Let's say you put penalties on all the airlines which emit more emissions, or you have carbon trading and some of the policies. So it's a long conversation on one chart, but I just wanted to put here that if you look at this, take a look at it, none of these challenges existed in the last 11 years since right since we have to switch over the entire process. We have to completely transform the aircraft business, the aircraft engine, the materials. We are going to completely change the fuels. Think of hydrogen, and and then hybrid electric. I will come to that in little later. So anything and everything around propulsion system is changing. And then we are talking about digital technology. We are talking about intelligent airports. So every aspect of aerospace engineering is going to see unprecedented change. And what is the beauty of this chart is that you are going to be right at this whole career. So if you put yourself as an engineer, you are going to start your career now and going to spend the next 30, 40 years, you are going to actually see these radical changes. So I call this as a Wright brothers movement, because when Wright brothers invented the first flight, there was no risk. There was, the aircraft concept or the propulsion system or the control system, nothing existed. There were no disciplines around, let's say mechanical engineering or electrical engineering or controls engineering. None of this existed that they had to invent. In the same way, I see for each one of you, we are going to invent the future of aerospace. Okay, so I talked about the radically different architecture we call as revolutionary innovation for sustainable enterprise. This is a technology program we launched during COVID. While the whole world was grappling with COVID, aerospace industry was really doing bad, but we saw the future, and the GE Aerospace we have launched, along with our partner Safran, we launched RISE program. You can see the engine, it looks completely different, transformational. We talked about hydrogen conversion, and then, hybrid. Again, 15 years ago, or 20 years ago, for sure, nobody knew about drones. Now drones are so much integral part of military age. That's the way we are going to bring the new age wars. But drones are also being applied in the commercial aerospace. Many cities in the world are thinking of urban air mobility, through drones, 2-seater, 4-seater passengers. There are at least 100 companies in the world. In India, we have 2 companies, one from our own IIT Madras, Professor Chakravarti and his company is as a startup. They are already working on e-plane. In India, there are at least 2 companies. All over the world, there are 100 companies. So we are going to see what I call as the democratization. So flight technology is going to be technology. And a lot of that will start from the startups. So the way I see the future of hybrid electric is, for anything around 8-seater, today there is a fully electric aircraft for up to 4 seats. But we can, as we look at the battery technology, the motor technology, and the safety, etc., I see that maybe up to 8-seater, we can have fully electric aircraft. Again, I'm projecting this for the next 25-30 years. At around 2050, you can see hybrid electric aircraft maybe carrying 8-seater passengers. And then beyond that, we would have a good business case for hybrid, meaning you have a small jet engine, also these propellers which are powered by batteries, driven by motor is driven by battery, and only during takeoff you need more power, so for which you will switch on the jet engine. Then once you are in the cruise, you switch off the jet engine, you can pretty much run on the battery. Right, so that I see the sweet spot for hybrid electric, maybe around 20-seater passenger. I think it makes a good business case, maybe 19 seats. But beyond that, we are not going to, I don't think we can replace jet just because of hybrid electric, because the batteries, the motors, the cables, the whole thing is power to weight ratio is so low that it can't compete, it can't replace the jet engine. So jet engine is here to stay, but in a different form. But then we are going to see a lot of electrification, as all of you want to use your electronic gadgets, cell phones, etc., in your travel or in the flight. So we are going to see increased need of customization and digitization, and for which you need more power. So more electric aircraft, again using batteries, motors, etc., will be there even on a larger aircraft. So I have just one more slide. Yeah, so couple of slides. So just wanted to give you an illustration of what are all the technologies which are part of this RISE program. How are we going to achieve? I think we covered most of this. We are going to see most of these components made out of 3D and metal 3D, okay, which is already established. Again, our company GL Space put the first 3D printed metal parts, fuel nozzles on LEAP engine around 8 years ago. They are running beautifully. They are talking about making many more parts of the additive manufacturing. We already talked about hydrogen, sustainable aviation fuel, open fan. There is no tug. We are going to use a lot of composites, a lot of advanced materials. We are going to improve both propulsion efficiency and also the thermal efficiency. And we are going to see this. We are going to do flight demos in the next few years. So it's not just a concept. We are going to put it on an actual aircraft, fly, demonstrate this capability. So again, just to illustrate a GA aerospace journey, every time, it's not very common in the history of aerospace that we come out with a whole new, radically new architecture. But you can see every decade also we are coming out with a whole new architecture, both from commercial aerospace and also from military aerospace. We think that the RISE architecture, the picture that I shared with you, would be the architecture for the future of propulsion. And so it's going to be transformation. And we developed all these programs in collaboration with NASA. You can see the first gear turbofan PIC program in 70s we developed with NASA. We developed the unducted fan. You can see in the 80s when the fuel prices were very high because of Iran-Iraq war. We came out with this concept. You can see the engine. The propeller is the UDF unducted fan. The propeller is on the back of the engine. So if we actually flew that aircraft, it was proven to be much more efficient, dramatically efficient. But there were some concerns around the noise, community noise. But we couldn't pursue because the war was over, and the aircraft manufacturers and the airlines were a little bit hesitant to go for a whole new architecture. And so on and so forth. We have the next generation fighter program called Advent in collaboration with the US government. Again, a radically different architecture. And we talk about the RISE program with OpenFab. Okay, so I just want to conclude exactly the 3 points that I mentioned. You should really take privilege to be part of aerospace. You are in college, you are going to study. I request you to please focus on the fundamentals, develop your core engineering expertise, knowledge, and we are going to see dramatic opportunities and challenges. So the future of aerospace is disruptive, as you know, right? We are going to work on sustainability. The aircraft is going to look completely different. The propulsion systems are going to be different. We are going to do a lot of additive manufacturing. We are going to see unprecedented use of digital technologies. So you will now agree, hopefully, that this is our right progression. India as a country, we have missed to be part of the aerospace growth, because while the whole world was discovering, innovating aircraft just after Wright brothers, in India we were fighting for our freedom. So it was a distant dream for us to imagine that India would one day develop its own aircraft. So we were having our own problems, but now I think it is going to be India's. That this century belongs to India, and in many industries we already see this in automobile, digital, whatnot. I truly believe that this century India is going to shine, be a big player in the future of aerospace, and I can proudly say that this July we completed G India Technology Center the first multinational company which has set up large scale R&D engineering center in India, GE. We have set up, we have completed 25 years. And I can tell you proudly that our center, we are working already on the future of aerospace, like aircraft, which the RISE program that I talked about, the aircraft which are going to fly after 15, 20 years. We have already started working from last decade. So we have already started playing a big role. But I am counting on each one of you to take this opportunity to make your own contributions and make India proud. So with that, I wish you all the very best. And if you have any questions, let's take for maybe next 3-4 minutes.
Sir, I have one. Professor Kala. Sir, in Pullinam Aerospace, we are working in electric two-seater, and we are aiming to build our prototyping certifications for next 3-4 years. How do you see the two-seater electric aircraft opportunities, 2 or 4-seater? I'm not talking about VTOL. How do you see about the fixed wing opportunities, especially if we are getting it 4-seater thing?
All other mobile phone something. Only one gadget can be on.
So how do you see about this 2-seater to 4-seater electric aviation opportunity in upcoming years? You discussed detailed exactly. What we are seeing is a lot of UAV focus is into industry. Similarly, people are talking about 90-seater, 80-seater, but you exactly said how 8-seater or 10-seater aircraft, electric engine what you are working on with Safran. How do you see to this the differences like 2 4-seater and the 20 30-seater?
No, great question, sir. See, as I said, there are literally hundreds of companies around who are already working on the advanced air mobility, UAMs, as we can say. It ranges from anywhere from 1 to 4-seater, 6-seater. There are all kinds of companies, some big companies. So there are 2 things I can share. Does that make a business case? Absolutely yes. I think for up to 4-seater, I think with the current battery technology, the motor technology, in terms of power to weight ratio, I think it's a sweet spot. However, there are 2 big challenges. The biggest challenge I think is around, remember, aerospace has become, the aviation has become the most safest mode of transport. And the safety is so impeccable, so hard, the safety is so great that we must improve, we must validate extensively is electric aircraft technologies. Because, in the past, again, I don't want to pinpoint any company, there are a lot of challenges. The battery management, thermal management is a big challenge. We have motors technology, but mostly from industrial applications. But we have to take the same motor technology, make it so reliable at the same level of aerospace. It's the same thing with batteries, thermal management. So there are inherent challenges. So the biggest challenge I see is actually the price, safety, and certification related. The second thing is it's more commercial, right? When there are so many companies which are developing the electric aircraft, can they make enough money? Right? Can the aircraft cost is affordable? How do we repair? How do we service these aircraft? It's a supply chain. The MRO network is capable of servicing. Right? So there are business related aspects. But there are equally challenging technological aspects which have been discussed. And there is no aerospace industry, there is no aviation industry. I think the real concern is around.
Sir, added to that, how do you see the role of SAF, Sustainable Aviation Fuel, and drop about the aircrafts, especially for the same 4 to 8 categories in future?
Yes, sir. I think sustainable aviation is aviation where SAF is universally, it is going to be applied irrespective of the size of the air. But however, if you look at, as I said, right, the sweet spot for electric aircraft, up to say 8-seater without any jet engine makes sense. Again, I'm projecting this for the next 20 years. Today, the power to weight ratio is not that great, so maybe 2 to 4-seater is the sweet spot. Beyond that, the aircraft will be a lot. So long story short, yes, for the 8-seater, I don't see any case of SAF. But beyond that, SAF will be a second. Again, we have to see what makes sense first and the mission of the.
Thank you, sir. Thank you.
Are there any questions? Any other questions?
Everyone, we can go for the vote of thanks. We will interact and students are little, they need to break their ice, like we need to make ice breaking from them. They are little hesitant, even though they are having, it is new for them, they are hesitant to interact with people, but it is a great lecture, sir. Now we request Dr. Sandil Kumar from Guru College of Engineering, Coimbatore, and also IEI Aerospace in Coimbatore local. He will be local center. He will be delivering vote of thanks.
Good morning, sir. So, to the audience, some information about Mr. D. Maheshwar. He has authored 5 technical papers on design, advanced FEA and national conferences, and he has 4 patents, US licensed patents under his name, and he has delivered nearly 250 keynote lectures in various national and international conferences. Currently, he is a chief consulting engineer for GE Aviation in Bangalore, India, and he has served several roles like COE manager and executive section manager for Aviation Advanced Technology Organization, and currently he is chief consulting engineer for GE Aerospace Aviation. And we take this opportunity to thank Mr. D. Maheshwar for giving the information regarding the topic on ongoing research in electric aviation and SAF for sustainable aviation. We thank Mr. D. Maheshwar sir and the organizers and the students. Thank you, sir. So sir was an NIT alumni, and so he is now the chief consulting engineer at the aviation. Thank you.
Thank you. Thank you. Thanks, everyone.
Sir, leave meeting.
Application engineer. My profile, as I mentioned, I work in the volatile academics. I work with a lot of IITs and IITs, research institutions for our region. Also, I work with the Asia Pacific countries in academics, as well as in the commercial accounts. So my major, I was a computational fluid engineer from healthcare to aerospace. I work on a different kind of application. Yeah, and I did undergrad from aeronautical engineering. So I was well comfortable with maybe the aeronautical and aerospace application. So CFD was well known. So answer is the CFD is a well name. But here I'm here to teach not only the CFD. So we have other line of simulation tools that we can explore. So let's discuss about our syllabus. Today in our syllabus, aerodynamics is one of the two important verticals that we have. So aerodynamics, yeah, CFD is there. And the two structures we have static mechanical. So we have another vertical. So for that also we have simulation, which we are very familiar. But we not stop here. We are revolutionizing the other thing, orbital mechanics, flight performance. So we have to learn STK. So in this next talk, I will take you through much more deeper insights into acoustic. And if you're taking an aeronautical bachelor itself, we can at least cover 4 to 6 laboratories in using ANSYS simulation tools. So that's all my. And also, I'm just going to address the challenges not only in academia as well as in the startups. How we can bridge the academic and industry. So how we can collaborate further? What are the new technologies that we are almost we are actually successful. So this is well known. So if you take a component level simulation, we are always tops here. So we'll do any simulation. Let's take a CFD. So we'll start with the simulating any turbine. We'll take any particular component from aircraft. We do the analysis. Or we'll take a computer aircraft structure to understand the drag or the lift of the particular aircraft. So we'll just focus on one particular component and we will try to integrate with the subsystems. So there is a subsystem level of simulation is also there and the system level simulation. So we as a multiphysics component, we can do a simulation from turbine to jet engine, component simulation and to the aircraft. So we are doing a complete package. So from component level to system level simulation can be done. So this is actually the industry practice which is in the room. So I'm here to bridge the multidisciplinary and interdisciplinary approach. So to build any aircraft, let's take a drone. Some of the mechanical parts is not only the issue. We also consider the avionics. So the multidisciplinary interdisciplinary approach to be taught from the direction from the campus itself. So that's the win-win of the ANSYS. So even not only the mechanical system, but also the electrical system, designing an antenna, fitting into the PC, and we can do the understand how the performance of the PC, and just testing with the complete system, how the communications happen, plus the lag is where the best part fix the antenna, all the problems arise during the performance of the particular vehicle. So these kinds of simulation can be done. So it's a knowledge from A to Z, we can do the simulation. And we then all stops with the system-based simulation. We also do system of system simulation. Let's take an aircraft. It's going to fly, it's going to take off from the Himalayas. And take another aircraft is going to take off from the southern part of India. So the altitude is different. The performance is different on the different environment. Also not on the altitude, but also there will be a difference because of the weather pattern. We can also simulate all this environment, how the particular system is going to perform. Okay, we can understand the endurance of the aircraft, we can understand range, where the fuel is burned a lot, where the power consumption is high, what is the reason of this, is it an environmental factor or system factor or any particular component factor or the component of the payload. If we add any additional payload in that particular aircraft, how the aerodynamics factors varies, how much weight is increased, how the mass reduction is there, fuel is burned, so mass will be reduced. So you can understand all the non-linear variabilities in the system of system simulation. Not only the mechanical point of view, you can also do the communication point of view. If there is any communication blackout is going to happen, how the system is going to communicate among them. There is an aircraft, and you can have a battlefield, and a missile is going to. So if there is any how the communication backflow is going to happen, and we can also do a what-if scenario. Okay, so if there is a battlefield is going to, so we are going to send a group of aircraft, and there is going to be communication between them borderline. So we can do a what-if scenario. We can also simulate the battlefield. So before going to an operation, we can simulate the complete operation and make sure that our operation is going to be successful. So that kinds of simulation can be done in ANSYS. So we are number one in designing simulation software. Yeah, we are leading the industry, and simulations are core business. So we concentrate only on the simulation. So we are not just deviating how prosper and the CE is also. We are basically simulation and will give A to Z package from any kind of component simulation to the system of systems. So we are highly trusted globally, and we are present in North America, most part of the Asia and European countries, and we have huge number of employees. I mean, employees, engineers, 400 plus engineers in different physics, and we are only external partner for support all the physics from fluids to optics. So and also there is good that we have multiphysics. So we can connect that. We can not only the fluids, we can also do the multiphysics. We can connect the fluids with optics, fluids with structure, and fluids with electromagnetics. So multiple tool connectivity can be done. So there won't be any interface problem between the solvers. So that's just a plus in our industry. So before I just want to go and I just want to why there is an even cost simulation. Okay, just from last 2 days we are discussing a lot of the challenges. Cost is a very important challenge. We have to reduce the cost. So what does it mean? We have to reduce the, if you need to do over engineering or under engineering. Why cost is that? We need to do a lot of experiments to come out of the product to be in the market. So we have to reduce the experimental cost. Second thing is we have to reduce the over engineering, and we have to predict where the failure is going to. We should avoid the failure. So let's take an example, Thomas Alva Edison. He tested 1,000 materials and found tungsten is the best material. You can do that simulation in using simulation. Instead of testing experimentally, you can do the testing virtually. Using computer numerical methods, you can do the test, you can run the codes, and you can check which is the best material. So same things, different physics we can do. Whatever is your challenge, whatever things you want to design, yes, we can do it using a simulation. You not to run it with the experiment. Okay, that's where we do. And we are idea theory. And second thing is we are modeling virtual assets. So what's actually happening in the experiment, we can do it virtual. Okay, there is no compromisation in the virtualization. Virtually making a complete operation as well as the second point is accuracy. I want to pause here for a minute. I just want you to go across. So just make sure how the switch will play a role for any development of your ideation. So we are starting with the ideation. So our ideation need to be improved. Our but we need to learn in a better than our ideation. That's possible simulation. Okay. So this actually happening throughout the world. That's the issue. Okay. So that's we are thinking of simulations. Let's take a simple design. I just want an example. Let's take a street light. Street light is a pole with a lamp. So there is no huge big design out of it. But still, simulation play a huge role. Maybe over engineering, cross ventilation, taking a huge pole across the city to just post it very transportation challenging. We need to dismantle it, maybe whether it changes a lot of variables involved, and what's the right position to place the lamp, and they have to cover the maximum area. They need to reduce the material usage, material cost. Even for a small lamp, there are a lot of challenges involved. So let's take an aircraft with billions spare parts. Let's take an unmanned area built as huge challenges across the environment, a lot of factors involved. So then, even for a small street lamp, there is a lot of factors. Then later, take a use system interaction where the environment matters a lot for the drones. So then you just think about the number of variables, number of factors first. So we have to run it before we are testing it. Maybe for a particular scenario, your drone may perform well, but maybe in another scenario, it won't perform well. Most of our, let's take a different drone, is made for 5 minute battle. Okay, so we can't assume things it will perform well. So we need to make sure that our performance marks should be 100%. That we can simulate. So that's our role of simulation. Yeah, we have a huge portfolio. So maybe whatever the physics, whatever your problem, what things you want to achieve, we have a solution in our one-stop solution. So here, let's take an answer student. We can do a simulation from subsonic to hypersonic, complete regime in a single shot. So we have a solution from all regimes, whatever the physics, yes, we do. So let's start with the material. It's a material library. So for your structural simulation, if you want any materials from various temperature or even biomaterials, yes, you can take it from the library. It's readily available. Scale is for a functional safety. For a, let's take a drone, for a lot of avionics comes around. So functional safety matters a lot for the avionics. So for functional safety simulation, we have scale. And cyber security, which is one of the key role in especially on this defense side. So we have cyber security safety analysis can be done, and based on the standards. So we have, if you're pitching for any startups, then they want to be maintaining the military standards. For as per the standard, we can do that. We can generate the cyber security tools. And the response structures. We have a well-known mechanical tool, crash analysis, LSN, forming, motion, a lot of solvers for a structure from explicit to implicit. So we can do a simply 0.01 second crack to accurate simulation. So all directions possible. And also fluids. So we have a bunch, and we are well known in the aviation industry. Fluids are well known solver inside of multiphysics and highly industry proven tools. CFX for turbo machinery, chemical for chemical simulation, and for icing engine and DPM simulation, US and webcam icing is just for icing simulation for aeronautical application. For aircraft going to high altitude, the icing is the biggest issue. So we have a solver for that. And yeah, we have extra process electronics. So if you want high frequency analysis or low frequency analysis or motor analysis, you want to develop a motor for an unmanned aerial vehicle, or you want to understand where to place the antenna, you want to understand communication between the aircraft. Yes, we have to. And we have to do for semiconductor and AV, we have AV simulator. Now drone taxis, automation drone taxis are using our AV simulation tool for building up from Abu Dhabi, Dubai, and even IIT Madras planes. They are all using our tools. And machine SDK, machine engineering is for developing a trajectory. If you want to do orbital mechanics, to understand the flight performance, flight mechanics of your aircraft, yes, we have to. And for acoustic simulation, we have and we also complete optical simulation. If you have any sensor, EOS sensor, third optics or infrared sensor, yes, we have a tool for that. If you want to do a light simulation, if you want to do a photonic simulation, if you want to develop any lens for your satellites, yes, we have a tool CMAX. And yeah, draw on, and we have a digital twin. So just to, you can virtually make your monitor your asset. Okay, let's take as a digital twin as a give you an example. Let's take a fitness watch. So fitness watch will monitor your health, and based on that health, you will take a decision, right? Similarly, you can put up a sensor on a drone. You can understand how much force acts on that particular drone. You can understand what is the pressure distribution on the drone. You can understand performance, when to do the maintenance, predictive maintenance. So if health is bad, you will go to the doctor based on the Fitbit watch. So same way, we can put a sensor on the system. We can understand, we can monitor the performance, and based on the outcomes, we can do the predictive maintenance. So these are where we have a team builder. So we have a complete suite. So it's a one-stop solution for any problems in the simulation. Yeah. And if you are focusing on a single physics, for there is an aircraft, you want to understand the pressure distribution, or you want to understand the lift and drag, or maybe it's an high-speed vehicle, you want to understand the shock phenomena, or want to understand aerodynamical analysis. Yes, single physics, yes, we are very strong. And multi-physics. Let's take a missile as an example. You want to understand how the missile communication is there when it's going in hypersonic speed. You want to understand the drag forces acts on the fluid side, and you want to understand the structural phenomena. Yes, here you can see that for a single missile, we use the HFSS, fluid, and static. So we are analyzing the electronics point of view, I mean the communication, and structural point of view, as well as the fluid point of view. So all three solvers have been used. Yes, we are good in multiphysics also, multiple physics, and also multiphysics. Here the two solvers have been connected, fluent as well as the static mechanics to understand the field structure interaction. And if you want to understand complex digital prototyping, you can prototype the complete asset and can understand how the prototype, how the performance of the system. And also the digital twin, as I explained, you can monitor your asset. Like, so from if you give a complex platform, the whole again is the simulation. Yeah, this is our major challenge. So this century's challenge for aviation industry is safety, sustainability, and affordability. So these are the three mantras. So whatever the industry, whatever the academia research it is, we fall into this. So fuel burn, we have to reduce the fuel burn, and we have to have optimized aircraft rate. Aerodynamic efficiency must be there, even a 1% matters a lot, and we have to have emission lower and lower, and noise. We have to be makes keeps noise less noisy. Plastics matters a lot. Maybe to the passengers or to the external environment to fulfill the standards and external service of life. So maintenance matters a lot. Maintenance cost. So for all this, we are already been for us, and we are also doing a lot in this. So these are achievements that we did in the industry. So we are well named SOLA. So the students who are coming out of the campus is extremely essential for them to be trained well in the simulation. So the simulation is something. If you take any industry, any OEM, there's a set of simulation engineers who do simulation for all the physics. Every product has more than 2 to 3 physics. And whatever the product, maybe from ceiling fan to the aircraft. Okay. So we are enrolled 50%. We are reduced by 2050. That's our goal, and 75% of noise we will reduce, and safety we need to foster. Safety certificates is also possible because they need a lot of paragraph, lot of different constraints. So these is the goal. So we have to make sure that as a stockholder, we have to produce skilled engineers to the society for the industry. So that's the major point for you. So I just told you it's a multi-physics. So for aerodynamics point of view, we have achieved airframe, aeroelasticity, even avionics or flight control, maybe the communication and electronics. So if you take an aircraft, all these 5 elements is important. So we can't make aerodynamically perfect aircraft. If you lose something on airframe or aerospace, definitely structurally it will fail. You won't get certified. So we have to make sure our students who are getting out of, 50 students are getting out of each batch. They have to be, at least 20 need to be fit in aerodynamics, other 10 need to be in airframe, and others need to be aeroelastic. So some people need to be in avionics and flight control. So these kinds of versatile knowledge and skilled engineers are required for the test. Okay, so that's how the simulations comes to the root, which will connect with your syllabus. So if you're teaching something, let's say you're teaching about the drag about in a syllabus, you can simulate and teach the student lively. This will even if you take our syllabus, the syllabus will cover all this. So, but practically learning experience is where the deficiency in the syllabus. So, where we can use the simulation to teach them to experience the industry in the campus itself. Let's take aerodynamics. So, a drag challenge, maybe a noise control, maybe handling a low and high speed, maybe from a supersonic or hypersonic icing. For all these challenges, we have a tool. And we have also proven white papers and proven research papers are available. So these are an example. So we have the aerodynamics variable controls and we have noise avoidance strategies are there always pursued. And from steady to dynamic, aerothermal loads, all possibility can be steady in the flow. Okay. And let's take an airframe and having a structural reliability of matters. So maybe a deformation, you want to understand the failure. Yeah, we can also do a composite simulation. So if a structure is in a composite, you can model the composite in our tool and you can do the simulation. You understand the crash analysis, you want to understand the fatigue, yes, possible. You want to try a different mixture of composite, yes, possible. Even want to understand the bird strike, yes. So with something where the researchers and the faculties can do actual research. So the problems which is in the society, they can take and they can simulate it and they make sure their idea is good. So their ideas start from imagination, but they need to prove it. So proving it, experiment is highly possible, but they can choose the simulation. Okay, but another sense, simulation is not that much tough. Our GUI is user friendly. Even a traditional based simulation engineer can also adapt it. Even a fresher can adapt it. Okay. So that's how we have designed it. And in aeroelasticity extenders, maybe a fatigue or maybe a flutter or any kind of aerodynamics and structure, both fluid structure and traction. So modeling these kinds of things in a laboratory is too costly. Okay, but we need to take a lively example to the students. Is possible. Okay, so building up a laboratory separately for all the verticals is extremely difficult, but that can be possible in the simulation. And even avionics and flight control. So where we need interdisciplinary and multidisciplinary. Our syllabus majorly focus on mechanical side of the aeronautics. Maybe 1 or 2 papers we'll have to a light during the application point of view we'll but to build up actual from the root, there is a lot of problems on the roots of avionics. So we need to do a multidisciplinary. So we need to collaborate with the electronic either EC or triple department, and where the students need to. So students can do a multidisciplinary. So from in the campus itself, students from aeronautical engineering can discuss and they can collaborate with other department and they can do research. So this will build up the platform for them in the campus itself to do a multidisciplinary research. Okay, even the faculty can collaborate. They can bring up ideas because they are communication side. They are strong enough. But in aircraft, how they use the communication with aeronautical engineers and aeronautical faculties will be strong enough. Don't say collaborate, but that's the platform. We provide a platform. And yeah, as mentioned, the communication side also. So if you're developing an aircraft, you're giving a solution. If there is an existing problem in the industry, we're giving a solution completely aerodynamics point of view. But you can't implement it because if you implement the communication and electronic systems will get into the failure. So we need to make sure that developing a solution efficiently in one vertical and compromising another vertical will never be a product in the market. Okay, it will be standard as a research platform. So if you want to take it to the market, we have to understand what we are going to compromise in another vertical and how we can go up. So these kinds of where we can also understand how the propeller, how the aircraft maneuver is going to affect the communication. Yes, these kinds of simulations can also be done. So as I mentioned, a multidisciplinary approach can be happened. The simulation could be a very good platform for the researchers and students to mingle together and do their research. And for simulation, right, we need high computational power. Yes, that's true. Okay, and for that we need a clusters. That's true. But we have a new technology GPU. So if you have with a small workspace, small workstations using graphical processor unit instead of CPU, you can run it in a GPU. So we are making you much more affordable in the hardware side also. So you can run a lot of the case in GPUs. First we have started with the external dynamics. Now we have come up with a lot of we remove a lot of limitation. We have a lot of turbulence models available. So ANSYS Fluent can run in GPU also. So you not to rely on the CPU. So your computational requirement will never limit yourself in the research. Okay, and without compromise. You can see even for a combustion, we didn't compromise CPU and GPU. You can adjust it, and it's very powerful. 2 GB is 16 times more than 128 cores. So we are making you a little independent from the computational limitations for your research. Yeah, I just want to take it. So most of the people think numerical simulation, which is we need to have a lot of codings need to be done, a lot of parameters need to be considered. So designing an aircraft, especially, it's very difficult. Yeah, that is true, but it's earlier stage. But now what we did is we have made a tailor-made. So Fluent app is a tailor-made. Just we can give an input. So what phase you need to see? You want to study in a subsonic or you are attracted to microsonic? Better tell what are the Mach number. What is the angle of attacks, from which angle of attack to which angle of attack you need to study? What are the maybe different airspeed, speed, different Mach number? Once you given a design point for the complete maneuvers of the aircraft, complete trajectory from takeoff to cruise to landing, what are the maneuverability of an aircraft? In a single data points will be generated. In a single simulation, we can understand the complete maneuvers of an aircraft. In a particular angle of attack for a different Mach speed, what is the lift and drag? So we will, in a single click, they can use, the students can easily set up and they can understand the physics better. So theoretically they will be learning, but they want to understand how the force separation is happening. In which angle, why in this particular angle of force separation, I have to change the aerofoil, what is it? So they can quickly do the design, they can understand. And there is a post aircraft design. So for aircraft design, majorly we use maybe Excel, right? Excel to understand, put that in different data. Because there is no physics-based simulation. For aircraft design tools, you can use this tool available. And we didn't even stop here. I just want to put to show how strong we are in multiphysics. So there was a problem in UV disinfection of the surface in aircraft, also in the ventilation system. So we need to use infrared lights to clean the aircraft. So manually cleaning during a COVID-19 is very difficult. So we use the ANSYS Fluent and ANSYS Fuse. This is a light simulation software. So when the air went to the ventilation bed, it will be purified. And similarly, we can use the spews, the light UV lights. So we need to understand how much exposure need to be, how long the UV lights need to be in the surface to build the virus and to be in the air. Yes, we did it. So even a tight sport, without going to at the time even an academician or OEMs, they can't reach the office. Sitting on the workstation, they did this. It's possible. Okay, even if it's in a tight zone, you can do the research. And I'll take one single example. Let's say there is a fuel tank. In the fuel tank itself, we have multiple problems. Maybe a filter, a pipe chain, valves, filling, sloshing, floating objects, flushing, inner things, pressurizing, evaporizing, condensation. So these are all the different verticals. So if you do deep dive, you can do a lot of multiple variables. You can do a lot of deep filter. For all this can be done in the program. In a particular component itself, we have a lot of research areas to be worked. But it's highly light. If you want to understand, we did a simulation, it will be static. But you want to understand how the fuel tank will be there while a rocket is launched. How the fuel is burned, how the fuel is filtered. Is it the constant fuel is being sent to the combustion? Yes, that can be simulated. So we are not, our simulation is highly, it's real time virtual state. So it's not just we are giving a contour or maybe getting qualitative or quantitative analysis. We can make it much more realistic virtual simulation. Now we are into the hotspot. So let's take if there is a startup or there is a student project have been started. So we want to solve any real-time problem. So we are saying we are designing aircraft. So first we will develop the concept. Then they will go to the requirement. They will understand the requirement. They will understand the design. They will implement it. They will test it, and they will train the people to use the product. And it will be in operation. And there is it will be a complete cycle will be going around. But if you take it up, if you want to let's say it's a mission, right? So if you're developing a drone for any particular operations, let's take we want to take a payload from point A to point B. Environment is different. Sometimes it will rain, sometimes it will be snowy, sometimes they need to do the operation in the hilly region, sometimes they need to do the operation in the desert region. The performance will vary, right? So meanwhile, they need to understand the operation difficulties. So if it's say they want this is the end area, but these all are unstitched. Okay, so the information will never go to the concept design again. So they all need to be connected in a single point. It's possible in the SDK. So digital mission engineering vision. So what we did is from conceptual design to the sustainment. So we are connected. So we have stitched all the gaps using ANSYS SDK. Okay. So if there is any operational challenges, it will be automatically updated. It will be, we can update the design, we can update the implementation, and they can go to the operation again. So this is ANSYS SDK. So also design of your aircraft, maybe the aircraft design goes, they can do the flight performance analysis. They can understand about the range of the design aircraft. They can understand what is the endurance of the aircraft. Even a drone, fixed wing, forward wing, helicopters, and what we stop here. We will teach orbital mechanics. So for orbital mechanics, to understand the one body, two body problem, three body problem, they want to do the interplanetary transition of the satellite. They want to design a communication satellite. They want to understand how communication blackout is happening. Maybe a geo satellite or a LEO satellite, or they want to from the launching to the putting a satellite in a particular orbit. All these kinds of simulation can be done. Okay, system can be anything. Maybe a satellite, maybe a ship, maybe a aeroplane. So any kind of scenarios can be simulated here. It's not only the Earth. We can also simulate any planets in the space. And we can also integrate the communication system. How communication system is getting affecting while actual performance of the performing the mission. Radar cross section. So sky is the limit here. So I just want to give maybe a space operation like docking, putting a satellite in the space. Yes, possible. So they can learn the subject, they can do the simulation, they can understand. Okay, as system, maybe designing an aircraft, drones, maybe every drone, every aircraft has a different requirement. Maybe a fighter jet, passenger aircraft, or the delivery drones. Yes, missile defense. Yes. UIR, maybe it's based on any infrared or optical sensor system. Yes, that can also be done. There's maybe out of communication and radar. If you want to simulate out of communication or a radar cross section, yes, it's possible. And situation awareness. We can simulate a scenario if a bunch of drones are flying off. Is there how the communication is going to be between the drones? Or there is a drone on the satellite. How the communication is going to be between the drone and the satellite? So they can design high altitude long and run aircraft, and then the high altitude long and run aircraft need to be about as a communication channel in the ground. Yes, it's possible. So they can taste the air idea. We can make the students to think, and we can make students to walk it out. So this will give a good flavor for students to start working and develop that great interest. Yeah, space mission in the system level, like electro-optical, infrared, or RF communication, altitude determination, passive or active mode. So, anything on the space side is completely possible in SDK. Okay, so we have NASA, civil and commercial organized space organization, most advanced R&D laboratories, and defense testing organizations are using our tool. So it's very essential for them if they want to get into the space agencies. So SDK is one of the essential tool skills that they require. and like the air mission systems. So they want to understand the flight performance of the drone, air system. Yes, possible. Not only in the high fidelity routes like aircraft specific performance, engine modeling, advanced flight procedure, or like getting up regulations according to the regulation. Also, they can also work on the sensor side, and they can also do the parametric study. If I'm changing the airfoil of the aircraft, what's the performance changing? If I'm changing the payloads, what's the performance of the aircraft? If I'm changing the any particular variable, how the performance of the aircraft is. So they can do it rapidly. They can change the ideation, and they come out with the good results. And yeah, we have used customers. These are our customers also. Yeah, if the student want to get into aeronautical or aviation industry, this is one of the essential skills. And we have advanced order systems also, because if you're working as satellite communication, or you're on an avionics site, yes, this is one of the important, so we are works from all major verticals in STK for space and defense. And we can also connect with the fluid. If you know the time, altitude, Mach number, and angle number, and angle of attack from the fluent arrow, you can simulate that trajectory of the aircraft. From point A to point B, how the aircraft is going to be. You can do a complete trajectory, you can understand the complete performance inch by inch, frame by frame. Okay, so STK will communicate with the answer fluent also. And we can also do this in the mechanical. Let's take there is a satellite. You want to understand the sun is there. So the earth is here, sun is there in the middle of the sun. So you want to understand the radiation loads from the sun. So that your satellites don't fail because of the sun radiation. You want to understand how the using the sun radiation, how your satellite is going to deform, how the vibration is going to be there. Yes, that can be done. So mechanical. So there will be a student who are good in mechanical. There is a student good in mechanical. They can implement that in STK, and they can understand. They can develop their satellites. And we can also do if you are adding excess payloads, maybe anything. If the aircraft is good, it's performing well, but you are putting any excess payload, how the performance is going to be. We can do it with answers in STK and workflow. There is already workflow is there, so they can do the CFD analysis. What is the change in the structure, how much drag and lift variation is there, according to how the trajectory performance is going to be, and they can also understand the endurance and range. And these are all the numbers. So we always encourage multidisciplinary research. So if you have an STK mission, you can also do a communication side, CFD side, and model center side, scale, mechanical, yes, full from functional safety to structure to communication to computational fluid and aerodynamics side, you can do all this. Okay, so this is a physics based, highly accurate. We are simulating the system of system, the complete environment to understand our performance of the product. This one for developing a drone, just a mechanical side or an aerospace tool alone will never work. So we need electrical engineering, other discipline. Even we can make sure the other discipline engineering also in the particular. Not only the drone, we can just remove the drone, just put a mobile phone. Even in that case, we need all these engineers. So we need a single engineering group cannot develop any product. That's the scenario. Okay, so we need a complete group of people to work together. So for that, a complete group of multi-simulation tools is required. Where we and how in the group. And so our organization, we have expertise in all the major physics and also the industry presence. We have huge industry presence in the commercial, as well as we have most of our IITs or our customers. So we work with a lot of prestigious research groups in academia, as well as we are also working with a lot of OEMs, startups, successful startups. So I don't know. So then we have a problem. So we need a skill. We need to train the faculty members as well as we have to train the students. So we have Answers Innovation course. So they are still, you can just go to Answers Innovation course. It's a free of cost for all the physics. For even for STK, you can do digital machine engineering. You can go into the particular tab and you can learn it for free. There will be even in digital machine engineering, there is a level 1, level 2, and level 3 certificates are there. So even students or faculty members, they can log in, they can learn it, and we also provide 15 days software free for the learners. So they can use it and learn, they can pass the exam, they will be certified from Answers. Okay, the faculty members can be certified from us, and they can start the research. And the students can also use it. And other than that, we also provide they want certificate. They can pay and get the certificate. So we will provide the any of our customers, OEMs, they're looking for skilled engineers. If you are certified, actually certified, and you will be considered. Students will be considered for interview. So it will be easier for them to get a career set. So we are also supporting the training the faculty members, also in the students. So skill development area also we are concentrating. And support model is also there. If you are procuring an STK from us, so it's completely new tool. We are training you, and you already complete the certification, you are certified. But for your particular research, for example, you are modeling on particular sample, but you are facing something, you want to understand what flow will work for your particular problem, or you want to understand there's some error in the software. So while you're working on this, you are facing some error, you model something wrong. So if you want to figure it out. So you need a support. So you can write to us, support at platform working within a 4 hours. You will get a reply. A support engineer will be dedicatedly will be there to support you through mail, and they will understand your problem. They will take a meeting with you, and they will try to figure out what's your issue, and they will fix you up. So we have multiple level of support. So first level of support will from CAT from India, and second and third level of support from the directly from ANSYS and CAT from Germany. Okay, this is something equal for all. So we will give you a support model also. So you are free to do a research using us. Your face problem, your PhD scholars are having any issues, they can write to us. Most of the IITs are working with us, and we support them in a lot of research activities. So, any doubts, questions? Like,
I'm planning to run quasi-static analysis on mental perspective. Quasi-static analysis.
okay.
For that, ANSYS has some limited tools. I thought of running the quasi-static analysis on metal structures. Then what would be the cost? Is it charged hourly basis or?
For license, you are.
No, you are the cloud service provider for ANSYS.
You are asking for the service.
No, you are a cloud service provider for ANSYS.
Yeah, we are service provider and also the license provider.
Yeah. I'm asking if I'm having a job to run in your in the ANSYS platform.
If you want your job to run by us.
Yeah.
Yeah, we do engineering services also. So it depends on the problem, depends on the size of your problem, time requirement, and the expertise requirement. We will charge in the engineering service. But this engineering service, mostly the OEMs are any startup organization will work, but it's very academia. While you can do it by yourself if you have a license, right? That will be a best way.
And the problems scalable.
The scalability is it that much complicated that scalability issue?
Yeah, I got it while running in the laptop.
Okay. So what I recommend, right? Actually, for academia, we are giving it in a very low price. Okay, the price what we are giving for academia is very less compared to commercial. If you offer engineering service, will fall in the commercial. So the cost compared to getting a license or giving engineering service, if you compare it, engineering service will be extremely higher. So what I recommend is, if it is take a license, try to run it in your facility. So that will be economically efficient. To give a service to us, that will be considered as a commercial. It will be charged in a commercial. It will be very huge. It's very less. We have academia program. Pricing, you asking. Please reach to Mr. Noor. He is our manager. So pricing area, anything on commercial area, he will help you. But I like to take any technical questions, or you want to understand how to connect the simulation with your course. In signing that terms, if you want to discuss, you can. Because I am a technical person, so you can ask. Technically, I can address it.
If we do a concept, if we are getting the result, it's very close to surely getting the close.
Yeah, we are gold standard to that, even excluding the structure. So let's take the problem in the structural simulation, right? You will take maybe a specimen to put it in a UTM, you will test it, right? But testing it as the actual shade will be difficult. So we can model it and we can do that's how the simulation. But Yeah, what you're asking is very true. The accuracy matters. But for 1 or 2% putting that in the experiment is very challenging, right? So better surprise selection. And you can't go to design by design. For one design phase, you have to spend it again. For one design, you have to spend it again. So you can do a multiple design and you can make it, you can fix one design, then you can, for the particular design, you can do the experiment. So that's how simulation works. Simulation will never take experiment completely, but it's reduce the cost on the experiment side. And you can really put up your different ideas inside. That's how
How
we.
many years this software by using the tool? How many years they have to complete to get a decent job like 5.5 lakhs per annum or 6.5 lakhs per annum? So how much hours they have to spend?
Actually, it's physics. It's every physics has the expertise. Student is there is interested only in computer fluid dynamics. Okay, so we have 3 certificates. So foundation is there, and then they have to go to intermediate, then they have to go to the advanced. And based on the students, even finishing the foundation, they can. Some students they have to go to advanced, then only they will. And it depends on the student to student scenario. But we will recommend we have courses. So because depends on the company requirement will also vary. Right? So I just want to, Department of Aeronautical Engineering. All our Department of Aeronautical Engineering, right?
All the engineering.
All
Only civil, mechanical,
Okay.
EC, everybody.
Everybody. Okay, let's take easy. If you have satellite communication as a course, you can take STCAN and you can offer this course for aeronautical engineering as well as you can offer the course for EC and civil. So where the multidisciplinary things will happen inside your campus. Let's take a mechanical an example. If you are offering a course in aero elasticity, you can also offer the course to other branches. So open electives is are possible a lot. So nowadays it's very extremely competitive. So private universities are highly competitive with even government organizations. So NIRF ranking, making an act, aggregations as well as other regulations. So we have to be extremely competitive. So we have to think something out of the box to be much competitive to attract students. So classification will play a good role, and we are definitely will support your vision and mission of your organization at any level. And if you are planning to do a PhD, if you are PhD scholars, definitely simulation will be the best way to have a good research path.
Any other questions, sir, ma'am?
Sir, is the MATLAB and ANSYS, how way they are different?
Okay. So ANSYS is a physics-based tool. Okay, let's take STK. As you said, it's a mathematical tool. Okay, so mathematical modeling is different. Physics is different. Okay. So mathematical modeling
Even physics, we have formulas to.
No, physics is not physics formula. Physics, in sense, you can run the
Say Newton's law, we have a formula.
you can't run the governing equations, right? For example, let's take a digital twin. You want to understand the
What is
difference.
digital twin?
Yeah, I'll give an example. Digital twin, I'll give an example. What's physics based? Okay. For example, we're putting a sensor in a any particular asset to collect the data. Okay, you can collect the data. If you do a mathematical modeling, you can understand what will happen. You can predict it. Okay, it will be in a prediction. You can't lively monitor what's happening in the asset. Okay, but in the physics-based equation, you can run the simulation. If you run the, let's take an aircraft. Okay, aircraft wing is there. If aircraft is flying between Chennai to Trivandrum, and another aircraft, same aircraft always flies between Chennai to Delhi. The both locations different, so the performance outcome will be different. The deflection of the wing will be different. The maintenance, for example, for Chennai to Trivandrum, you have to do 1,000 cycles. But Chennai to Delhi, after 500 cycles, you have to change the span. So how do you protect it? Exactly what is actually happening virtually. It will be physics based. If not, it won't be accurate, right? If it's mathematical modeling. You're getting it?
Mathematical modeling will not be.
So we'll do a physics based simulation. You can use FEM, finite element method. You can use a numerical simulation. And we use Maxwell's simulations. So Maxwell equation is used.
It means input output data modeling, input output.
Depends on the application and scenario it will vary. if you take a main case, you will put a strain gauge, right? You will get a strain, and you can put up a simulation. You can understand how much it's getting reflected, right? That is how you do it in a mathematical model. But let's take in a digital twin. You will know the air speed of the aircraft. So for that particular air speed, you can collect the data, varying air speeds, and you can put it in the CFD, and you can understand how the deflection is using a finite element method as well as gowning the continuity momentum equations. Okay, so it runs on the gowning equations. So we are using physics-based equations. Now we are not doing a mathematical model. That's the difference. It's not a mathematical engine. Okay.
Gathering the data with the physical parameter data you are gathering. Yes. With that you are doing the
Yes, sir. Okay, sir. Let's put it if you are testing an antenna in a laboratory, okay, sir, and you do a mathematical modeling for the particular antenna, and you understand this antenna will work, and you are okay. Let's put up a scenario. If you put in an actual working scenario, in a particular antenna is there, maybe due to the placement or due to the environment, there will be a noises. You can't predict that in the mathematical model, right? But we can do these predictions things in a simulation. That's an advantage. Where in a mathematical modeling, we can't use Maxwell equation. Numerical simulation cannot be used. Here we will use a numerical simulation. Numerical simulation will be both math as well as physics. But mathematical model is rely only on mathematics. So you stop only in the mathematics, we will take to the physics and we'll apply the physics also. So actually, if you go with mathematical, you can't do a virtual asset. You can't make it as a virtually what's happening. For example, the accuracy will be very poor. Okay, if you're taking a satellite, let's take a satellite. You put it up a satellite, I put it on 150-kilometer altitude. You think there won't be a track? There will be other external environment. We can't model that in a mathematical model. We will plan one particular trajectory, but the accuracy will be very less to do a mathematical model. We go with this physics-based simulations, so we can model actual environment and we can understand the complete performance of the satellite. Maybe a structural point of view, maybe in a fluid dynamics point of view. Yeah, whatever. In the material properties also we can do. Mathematical modeling, it will be difficult. You can only work on only particular application. So that we need a physics, because nature is down by physics, right? So based on the particular verticals, we made fluids or electromagnetics or structure.
Sir, I have one question. This satellite orbit exhibition and all, can we do it for interstellar mission only for geo?
Interplanetary missions also they are using.
All period in
Sorry.
It's
a one two body problem, right? 2 body, 3 body problem. Just want to understand what's the gravity of the mass.
equations and all.
Yeah, in STK we can. It will be all in the behind the solver. It will do. Even in a fluent arrow, we can do just changing atmosphere. So Earth to Mars, you can simulate the Mars atmosphere. So you can understand what's the re-entry of your vehicle in the Mars. That's just changing from Earth atmosphere to Mars atmosphere. So we have the completed of the Mars atmosphere in the solver. You can also simulate the aircraft performance. I mean, if you're putting any re-entry vehicle in the Mars, you want to simulate that. That in a single thing you can change from Earth atmosphere to Mars atmosphere. NASA is using fluent arrow. We are already operating a lot of things using fluent arrow. So true temperature model is widely used in NASA. Any questions?
Any other questions, sir? No?
Okay. Please use it as innovation course, and please encourage your students also to use as innovation to learn access. Thank you so much. Thanks a lot.
Sir.
Thank you, sir. Thank you for explanations about the simulation softwares, how we can use for all the things in our aviation industry and also in other industry. Hope our faculty members have been benefited with that, and we might get in touch with you through your mail ID. And it's time to honor Mr. Vignesh from Cather Manchester. I would like to call upon Mr. Suresh from our famous Faculty of Aerospace Engineering who conducted all these talks, and he's also responsible for our CAD software in our aerospace department, to honor our chief guest with a moment. Thank you, sir. Thank you, ma'am, and thank you, sir, for joining us. Thank you so much.
Seen in Chennai and Bangalore and Mumbai kind of region. So it is a success what we have received from that. So with this, I am very happy to welcome Sir. Sir is India's one of the great aerospace leader and founder of E3AI, and also Professor Aeronautical Engineering in IIT Madras. And he was a co-founder and mentor for Nikun. And also, Sir have mentored say like top-notch startups which are all working on rocket propulsion, AI, drone-related activities, and also hyperloop and all those things. I will share Sir's LinkedIn to all the students. Please go through and have a look about it and the activities what Sir have done and what are the achievements I have done. Please follow Sir. And with this, I welcome you, Sir. Please say this to you.
Can you all hear me?
Yes, sir.
Very good. Great. Thank you. So let me actually talk about eVTOLs and advanced air mobility, particularly in the Indian context, without further ado. So let's actually understand what is the advanced air mobility. The advanced air mobility is actually an integrated approach to drone, eVTOLs, and general aviation. General aviation is actually again a broader term. People who are actually having private aircraft, like small aircraft, two to four seater kind of hobby aircraft, sports aircraft, even business jets, all of those things are all privately owned. And we also have commercial aircraft. So all of that stuff comes under general aviation in the context of what we are talking about. eVTOLs are actually what is called as electric vertical takeoff and landing aircraft, which are meant primarily for very short haul and urban air mobility in the 20 to 40 kilometers kind of distances for us to fly. And that is something that's actually the new thing that's happening. So the purpose of this presentation is eVTOL, because the new kit of the block, as I said, for the next big thing, as we want to call it. And question is how to roll it out in India and how they integrate with other tools, drones and general. Sitting in the middle between the drones and the generalization, how are we going to actually plug this into that? I'll start by actually having one 1-minute video about what we do at IIT Madras and ePlay, and so that are you able to do it?
Yes, sir.
So that's why it is visible. Explain
what they are doing, the composite fabrication, what they are doing. Slowly. It will be only for him. He has not shared anywhere. It's done by very young team. India's first, startup which is working on VTOL aircraft.
So let me just go back to the presentation. So that's what we're doing. So where are we in the world? You can see that there's a global trend and actually apart from mobility, there is at least about half a dozen of them. US, they listed about 2 or 3. There is one in Brazil, one in UK, some of them in Germany, quite a few in China similarly, and maybe a couple of them in Japan and in India. We have been actually the most prominent doing this. So the aviation authorities around the world are actually working on 11 standards and policies. We will actually discuss what are those policies. The global trends are there is eVTOL certification and urban air mobility infrastructure. These are the two pieces that people are actually working on. There is significant amount of funding that's being gone into the electric vertical takeoff and landing aircraft development itself, about $10 billion. I think this is probably this will probably become like about $11 billion since the time we made this presentation a couple of years back. And we are expecting the operation to happen sometime around next year. Is there somebody who is kind of asking questions? Can we move on? So in the India context, actually what we should worry about is the movement of both people and cargo is increasingly getting bigger. And people spend about more than 3 years of their lives stuck in traffic. If you think about it, then there's about 12,000 metric liters of million liters of fuel that is actually being wasted simply because of congestion. And as opposed to helicopters, eVTOLs actually are the most affordable solution that we should be. The market size is actually very large. We have conducted a market survey where about $1 trillion worth of economy is expected to happen by 2040 globally, in which the India TAM itself is actually the total addressable market is actually about 200 billion, 20%. US would probably command about 23% of the global market, and China would command about 26% of the global market. The rest of it then goes to European Union and other things. We did conduct a survey among 12 cities where we found that in India, close to about 78% of the customers actually preferred an air taxi service of a particular segment of people. And then similarly, in the B2B space, the businesses, about 76% of the customers actually prefer an air cargo service very similar to air taxis. We did actually give you the breakup of how somewhere between Delhi all the way to Chandigarh, Ahmedabad, all these people. We've actually asked questions like what do you want for access, what do you want for operational mode, what about service type and capacity. So we have all the granular details which get summarized in this particular picture. In this graph, we say that for access, people are wanting to be landing near to where they are. So be a very, very short wingspan kind of aircraft, which you don't want any wait time. They want to have like a, in fact, I think at the bottom you have a capacity. So more people prefer a 2-seater than compared with a 7-seater because they don't want any wait time for other seats to get filled up and so on. They want to get in there and then move on. They wanted piloted first of all, and then they wanted to become like a personal taxi and all that. So this is something that bears out what we think. Based on this, we also constructed what will actually be the ramp up in terms of the number of trips that happen in millions per month, and then the number of such taxis that are required in thousands. And you can see that they go hand in hand between, let's say, next year, 2025, all the way to 2040. To just give you a number, 2030, there are about close to about 200 million trips per month that will actually happen with about 2 lakh taxis in 2030. That's the kind of demand that is expected. So what are the speeds that we have? We are only having about 5 to 6 years for us to actually get to about 2 lakh taxis and about 200 million trips per month. So how do we get there is we need to work on a lot of policy initiatives and so on. So there are 5 points. One is, for example, the eVTOL development and the design, prototyping, testing, certification, as to traffic management, UAM corridor, flight path authorization for air traffic control. Where are the landing spaces? What will be the working hubs, working ports, working stops, pilot training, and MRO. In this particular talk, I'll spend more time on the eVTOL. I think we have already seen a video for about 1 minute. I think that covers that part. I won't spend too much time on that. But I will spend more time on the aircraft management and the landing. Just touch upon the pilot training aspect, but I won't bother too much more about it, given the time that we have. We'll skip go to the aircraft itself. What we are having is actually the most compact. It has a very short footprint when compared to everybody else. Plus, it also actually has very wingspan itself have things go a long way in a single charge, but it can also do very short, multiple short charge. That's actually the USB we have. We also have these good. And this is important actually we carry capacity condition and what is the amount of speed that it costs, right? So for about something like 8 times savings in travel time, we will probably charge about 1.5 to 2 times the Uber car to charge, and then we can still make a significant amount of profit per trip. So this doesn't be the estimate. So this is actually going to be starting from the pocket for upper middle class people that live in most cities, and put them over the rooms for other people to. The certification outlook is that we think that can get a fairly over certification of the what's called through its configuration. Subject forward propeller for the propulsion and the for vertical landing. We don't have to just for some level of reliability to be certified. So on. So tendency is something that we have, and we actually are the first private company to have a full-fledged design organization approval for a full aircraft to be designed, and lots of other safety features that we have. So it's actually our timeline for getting the certification going. So it's about a 2 to 3 year time frame that we already started from the design organization approval last year. So let's actually look at the airspace management. I think we have only 10 more minutes to try to finish the airspace management and the landing phases and so on. So what we will understand is that the urban air mobility piece will actually have to fit in the middle of the drones, the general aviation. So, and the drones actually right now allowed to fly up to about 400 feet AGL. So we want to then say, give a good margin between 400 feet to about 1640 feet. We just talked about some 500 meters sort of distance at half a kilometer that is, and then go all the way to something like about 1.5 kilometers. So that's the kind of band that we want to have, about which you can actually start assembly. The question that we have to ask is, what happens when these things intersect? You can have a band for forward flight, but what about when they intersect? And when will they intersect? All of them will have to come back to land, and then they will take off from land. So there is an intersection that is possible between the drones and the UAM and the general aviation and so on. So if you now look at a typical flight path, the typical flight path is actually going to look like this. We will take off vertically up to a certain height, then we will climb in inclined manner. Up to a certain point, we will actually have the vertical rotors continue to support the weight of the aircraft, beyond which the control surfaces, the ailerons, rudder, and the elevator can now kick in because you are accelerated to a certain speed where the wind will allow for these control surfaces to become effective. So you can climb like a conventional aircraft from that point on to your cruise altitude, and then you actually do the entire reverse thing. You start descending in an inclined manner, and then at some point you have slowed down so much that your control surfaces will no longer be effective when you have to have the vertical rotors kick in to start balancing the weight of the aircraft for the further descent, and then you get to the point of landing, and you have to do a very short vertical landing very as accurately as possible. So since this particular trajectory is sort of frozen, there's always going to be the mission to happen. We can then think about like non-intersecting flight paths between multiple flights that could happen simultaneously, so that they will all actually get different altitudes at which they will work, and whenever they have to crisscross, they will be crossing at different altitudes instead of the same altitude, so that they don't really pilot will have to take. If at some other point, some other a fourth point, you have to take one particular path. These two paths will never intersect. And they will have a vertical clearance between them and so on. So we can actually start with currently, like let's say, for example, if I'm having only 5 to 10 eVTOLs and about 10 to 20 landing sites within an ATC range, current ATC, like the airport ATC. In the next couple of years, you can actually use the existing helicopter operation. That means you actually pick up the phone, you file a flight plan, you get a flight path authorization, and then you go execute the flight. Very unlikely that you will actually have another aircraft which is also taking off at the same time from some other point and then crisscross this particular flight path. So usually you will have one flight that is executed completely before another flight happens anywhere in that geography. But the next level will be when you now go to about 20 to 50 eVTOLs and about 5 to 100 landing sites in a city. Then we have to get into like a automated flight path generation algorithm. And we will start with it being static. It means that we can have these fixed non-intersecting flight paths, which will have to be followed by the pilot, and the pilot will actually have a display of how well he or she is able to follow the flight path like typical rocket-like trajectory. You see all these rocket launches, you'll have a predetermined flight path, and then the rocket's trajectory, and then you'll have this the actual location blinking all the time, so that we will be able to track whether it's following exactly the predetermined trajectory. And all of these will actually be live for the ATC, so that the ATC is just watching. He's not trying to direct anything. He's just letting things happen. He will see only the deviations and not get distracted by people who are following the flight paths. But when you get to about hundreds of eVTOLs and about 200 plus landing sites, then it becomes a lot more complicated. So we have to have like a blockchain-based, a instantaneous flight path generation prior to every flight that is dynamic, so that you will be able to still have non-intersecting flight paths, but they will not be fixed in this thing we call for all time. They will actually be up, below, or above, and so on, depending upon other flights that are happening. I want to point out that these actually call for trips that are only about 10 to 15 minutes, which means that every aircraft will probably go through about 50 trips a day when compared to a typical taxi. A typical taxi that does about 10 to 20 kilometers, 30 kilometers kind of trips, it can do only about 10 trips or so. So it can do about 5 times more than what a typical ground taxi does. So it actually can remove that much amount of congestion without having that many number of aircraft in the air. So that means you have to understand that if you have 100 eVTOLs in the air, it's equivalent to actually having 500 taxis on the ground. So you don't need that many eVTOLs in the first place. So this kind of depicts how we will go in the direction of starting from current helicopter operations and then get into automatic flight paths, and then ultimately by about 2022 we want to even have a mature state where even the pilot is not required. You can actually have a completely autonomous aircraft where the pilot is just, so you have a control room where there are pilots that are just watching this and then manage that, and then remotely controlling the aircraft if required. Now the question that arises: what happens when you now try to intersect with the general aviation, which is typically runway based? So this is actually a picture of the Bangalore situation. So Bangalore, for example, the Bangalore airport actually has a air corridor that's given in the blue. Then there is Alhambra Airport space that has an air corridor that's given in red, and so on. So what we want to do is to go around these air corridors up to a certain height. So we are actually given a certain height. These air corridors will intersect that height. In that intersection, we can't cut across these air corridors, so we will actually have to go around and navigate. And that can be built into the flight path planning in the first place. So we'll still get like the shortest path that is possible that does not cut across the flight paths. Now, very similarly, we also actually have to have drones have to go around a kind of a funnel that is right above the landing site of a eVTOL. So all of these eVTOL landings, takeoff and landing sites will actually be regulated in the first place. There are regulations that are getting developed, and they will definitely have a clear airspace above them up to the altitude that we need to go to. That means, I mean, there are people who have asked me questions like, oh, what happens if you have wires crossing and, tree branches and all those things. I mean, the answer is we will not land there. We will, right? So we will have to make sure that the landing spaces actually have a clear airspace. So the clear airspace will have to actually kind of be conical, similar to how the air corridor around the airports are conical. And so if you are having drones up to the 400 feet, you have to make sure that the drones go around these, the conical trajectories and so on. So that will become like the red zone for the drones, and they cannot cut across these red zones. So the last point that I want to actually talk about just briefly is what do we do about the landing spaces? So we need to have these gardens called verticaps, vertiports, vertistops, and what are the associated charging infrastructure. So these standards are actually dependent on the aircraft dimensions. Typically, you have a 1.5 times the maximum dimensions of the aircraft that is required for the takeoff and landing, the location, and about double that for the taxi bay. So these are now being adopted in India as well. So India is developing vertical. What we would like to present here is actually 4 kinds of landing spaces and associated charging infrastructure. The first one is actually verti-hubs, which are kind of like parking lots, rooftops of parking decks, rooftops of malls or metro stations, those kinds of things. Where we could have space for about 6 to 10 planes, and we can do something like about slow charging. Slow charging in the context of eVTOLs is actually about 45 minutes. It is not like about 6 hours that it takes for your ground vehicles, because we fundamentally have batteries that can discharge very fast, which means that they also have the ability to be charged fast. And that's the reason why we will actually be able to do slow charging in about 45 minutes or 1 hour kind of time. The next level is actually to have something called vertiports, which could be existing helipads, rooftops of smaller buildings, fronts of malls, those kinds of things, where you have space for about 2 to 3 planes, and where you can actually have some fast charging options, like about 15-20 minutes kind of charging time. You can then have what's called verti-stops, and here we would like to distinguish between 2 kinds of verti-stops. One is public verti-stops, where you can simply have specially designed very compact landing spots with very little footprint on the ground, like your metro construction where you have just a pillar, and this pillar will actually have a flat top where the landing can happen, and the pillar can also develop as a lift shaft for people to go up and down from the ground to that place and so on. So there is very little ground space that is actually occupied by this verti-stop. But you can actually put like rapid charging stations which can top up the charge of a aircraft that is just landing and taking off, and having passengers go in and out within about 2 to 5 minutes. We can just rapidly charge. And the last one is of course private verti-stops, where it will be rooftops of apartment buildings or office buildings that are privately owned, but they have facility, they conform to the standards and so on. Let's say apartment building owners will then start coming up with, just like how they're offering things like swimming pool, gym and all that stuff, they will start saying that they also actually have a verti-stop on their rooftop, which is just space for again 1 plane, but absolutely no charging infrastructure. So this is actually again a sort of a depiction of, let's say, about three stops on a relatively small building, where you have one plane take off and another plane land sort of picture. The last part I think is about pilot training. I just have only 1 slide about it, where you have to understand that there are about 1.2 million eVTOL pilots needed by 2040, according to the estimates that we have. These are actually more automated, so it is easier to fly and lesser workload. But you have to keep in mind that the pilot's load actually is very critical during takeoff and landing. And these takeoff and landing are going to happen very frequently. That is, every 10 to 15 minutes we'll actually have a takeoff. So there are shorter mission cycles that can become very fatiguing for the pilot. That's something that we have to keep in mind. And we will fundamentally actually work with single pilot operations, where you will have a larger interface with the customer, so they will be customer friendly and so on and all that. I think the nature of pilot requirement, I think you just talked about it, I can skip this slide as well. But one thing that I would like to point out is electric aircraft actually allows for pilot training to be very inexpensive because you don't guzzle fuel during the training of the aircraft. It's a very good opportunity for us to train large number of pilots with electric aircraft. That's something that we would like to see happen very quickly. And similarly, we also actually can work on simulators for pilot training. So we'll actually have certified simulators that are coming out of India. One of our partners is doing this, so we can actually show simulators and go to simulator training before we actually do flight training. So it becomes the less expected. So I think, as I said, I skipped this MRO part. There isn't much that I have much to talk about, and that's about it. Thank you so much for listening.
Thank you, sir. It was an inspiring session indeed. It's very new for our students from Punjab region and also for the IEI chapter members who are watching across Tamil Nadu and India. So if you have any questions in that, you can ask, you can interact. And feel free, even if you want to ask in Tamil, no problem. Tamil பேசலாம். தமிழ்ல ஏதாவது டவுட் இருந்ததுன்னா சார் கேட்கலாம். கேளுமா.
Hello, sir. Good afternoon, sir.
Yeah.
So my question is, nowadays people saying in aerospace and in aeronautical sectors, the AI plays a major role, and AI almost occupy all the jobs. So what's your point of view on aerospace and aeronautical? How AI impacts on it?
So we do actually have a good amount of AI packed in our autonomy stack. So what we mean by autonomy stack is how close can I get my aircraft to become autonomous flight. So let me try to explain what is meant by autopilot versus autonomous flight. Autopilot is today existing in current aircraft that will take off from a runway, from an airport and then land in some other airport. The pilot does not have to do anything. The flight path is actually put in as given by the ATC with what's called as waypoints, and then the entire path is actually planned automatically, and the aircraft will take off and land automatically. The pilot does not have to. They are mandated to actually do manual takeoff and landing, every 2 or 3 flights because they don't want to actually get the pilots to get rusty with their hands, so they have to be practicing and so on. But that is nothing to do there. It is all sort of like deterministic or rule-based. You have plugged in formula, those kind of. But what we do is one step more. We actually put a lot of cameras and lidars and radars for determining what is the kind of obstacle force that is around the entire aircraft, and we use AI for mixing like how multiple different cameras can display the obstacle view. How can you also get depth perception with the lidars and mix it with the cameras? So these things require a lot of AI where we learn from what's called ground truth. That means that we have to have a lot of real data where we put these cameras and lidars and together to know these values and then train an artificial intelligence algorithm to figure out what is the field of view, what is the depth that we have, where we can sense an obstacle, and so on. So we can also actually sense obstacles that are suddenly crossing, because the human eye, for example, is used to see movement rather than static objects. Very similarly, we can train algorithms to sense movement so that we can actually look, detect dynamic obstacles to overcome. So these are things that we are actually using, what is the thing called AI for this. Going forward, we can actually get the entire flight control itself to be artificial, AI governed, very similar to how birds actually navigate today, and so on. But we are not very sure whether certification agencies will accept that. But there is work that is starting to happen in that area, and maybe 10 years from now, 5 years from now, the certification agencies may accept it, and then that could actually be more robust than compared to all the control law based algorithms that are currently being used.
Thank you, sir. If you want to.
Sir, good afternoon, sir. I am Professor Davamani from Mahindra Engineering College, Namalkal, sir. Sir, actually, as you said, the plans will be implemented from 2025 onwards, and in 2040 it will be lakhs air taxi will be available. So the pilot will be required more, and the infrastructure changing in the infrastructure is required more. It will be implemented in 2025 itself, sir.
We expect that, I think, see, this presentation is something that we made to the Ministry of Civilization last year. And at the time, we were actually thinking that it could be 2025. It could be 2025 or 2026. In the next couple of years.
Thank you, sir. It is very much interesting, sir. Thank you so much.
Thank you.
Good afternoon, sir. Myself, Keetana. Drones வந்து ராக்கெட்ல கொண்டு போய் லைக் மார்ஸுக்கு வந்து அங்க வச்சு ரிசர்ச் பண்ண முடியுமா சார்? ட்ரோன்ஸ் ஆப்ரேட் பண்ணி இங்க இருந்து
மார்ஸ்லயா? சரி, I mean, only thing is, மார்ஸுக்கும் எர்த்துக்கும் வந்து ஒரு I think there is a 10-minute gap at the speed of light. So நம்ம இங்க ஒரு கமாண்ட் வந்து கொடுத்தோம்னா அது 10 minutes எக்ஸ்ட்ரா மார்க்ஸ் இருக்கும். அண்ட் நம்ம வந்து நம்ம இப்போ ஃபார் எக்ஸாம்பிள் மூணுக்கு சொல்றோம்ல, ஒன்லி ஒன் ஃபேஸ் ஆஃப் த மூன் ஃபேஸ் லுக்கிங் அட் த பேக் சைட் ஆஃப் த மூன் நம்ம பார்த்தது இல்லை அப்படின்னு சொல்லி. அந்த மாதிரி பார்த்தீங்கன்னா நம்ம வந்து we need to have a satellite network around Mars. If you are landing நம்ம பேக் சைட்ல போய் லேண்ட் பண்ணிட்டோம் அப்படின்னா நம்ம கமாண்ட் இருந்து ரிலே பண்றதுக்கு சேட்டலைட் இருக்கு. சேட்டலைட் வந்து நம்ம கமாண்ட் பிடிச்சி அதை கொண்டு போய் அந்த மாதிரி சிஸ்டம்லாம் இருந்ததுன்னா இன்னும் கொஞ்சம் டிலே அதிகமாகும். ஸோ அதனால இப்போ என்ன பண்றோம் அப்படின்னா மார்ஸ்ல வந்து ஒரு ஹெலிகாப்டர் வச்சிருக்காங்க போன வருஷம். அந்த ஹெலிகாப்டர்லாம் வந்து ஆட்டோனமஸாக தான் கிடக்கும். ஸோ இங்கேருந்து கமாண்ட் பண்ண மாட்டோம். அங்கேயே அதனுடைய மிஷன் வந்து ஏற்கனவே அதை இன்புட் பண்ணிட்டோம் அப்படின்னா நம்ம ப்ரீ ப்ரோக்ராம்ல வந்து நம்ம ஆப்ரேட் பண்றதுக்கு வசதி. இங்கேருந்து நம்ம ஆப்ரேட் பண்ணோம்னாக்கா ஒரு 10 நிமிஷம் லேக் தான் நம்ம இங்கேருந்து பண்ண முடியும். அது நம்ம சொன்னதை வந்து செஞ்சுட்டுன்னு சொல்லிட்டு நமக்கு தெரியறதுக்கு நிமிஷம் ஆகும். ஸோ நம்ம கமாண்ட் கொடுத்துட்டு ஒரு 20 நிமிஷம் வச்சுலாம் நம்ம அது நமக்கு என்ன நடந்ததுன்னு தெரியும். அதனால லைவா பண்றது.
Thank you, sir. It was very inspiring, and we really thank you for readily accepting the things. And we are honored to have you on our seminar, along with this today thing which is going as a marathon for us. We had a great day, and even many people have commented that indeed the seminar was similar to how it was in other cities. Through online and through socials we have reached. You are also following what we are doing, and every industry across India, every aerospace people knows about what is happening in Punjab, and we are getting a lot of messages also. We had a lot of challenges, and we are very, very happy. Like in upcoming years, we want to have tremendous kind of events, especially in this kind of region, physically also. We had today 3 sessions on online modules and session. So thank you so much. Thank you for delivering us, sir. Thank you for the opportunity to host you. Thank you.
Thank you so much. I'm very glad that you are conducting this there. Happy to participate. I hope my talk was useful. Thank you so much.
Thank you. Eight years முன்னாடி ஆரம்பிச்சாங்க. அவங்களோட சின்ன சின்ன மிஸ்டேக்ஸ் வந்து அவங்களும் லேர்ன் பண்ணாங்க. இந்த ஸ்டார்ட் அப் டீம் ஒவ்வொரு ஸ்டார்ட் அப் டீம் அக்னிகூல்ல லேர்ன் பண்ணதை ஈபிஎல்ல கனெக்ட் பண்ண மாதிரி அவங்களோட லேர்னிங் ப்ராசஸ் எங்களுக்கு தான் ஒரு பெரிய லெசனாக இருந்தது, ஒரு ரெகுலேஷனாக இருந்தது. ஸோ அதை நாங்கள் ஆஸ் அ ஸ்டார்ட் அப்ஸாக வி ஆர் ஃபாலோயிங் இட். ஸோ அவங்களோட சப்போர்ட் இன்டு தட் ஹைப்பர் லூப்ல என்ன அப்படின்னு அவங்க ஷேர்
ஃபார் எக்ஸாம்பிள் வந்து நம்மளுடைய லைக் சொசைட்டில இருக்க ப்ராப்ளம்ஸ் தான் வந்து பார்த்தீங்கன்னா ஒரு பிஸ்னஸை கன்வெர்ட் பண்ணணும். சோஷியல் ப்ராப்ளம்ஸ் வந்து நம்ம நல்லா அண்டர்ஸ்டாண்ட் பண்ணணும். இப்போ நான் சென்னையிலேருந்து தஞ்சாவூர் வரணும்னு வச்சுருக்கேன். என்னெல்லாம் பாசிபிலிட்டிஸ் இருக்கு? எப்படிலாம் நான் வரலாம்? ட்ரெயினில் வரலாம், அப்புறம் பஸ், நெக்ஸ்ட் ஃப்ளைட். ஸோ வந்து நமக்கு இத்தனை 3 ways ஆஃப் டிரான்ஸ்போர்டேஷன் சொன்னீங்க. இப்போ ஒரு அர்ஜென்ட் பேசிஸ் நான் 6 o'clock நான் தஞ்சாவூர் போகணும், சென்னையிலேருந்து நான் டிசிஷன் எடுத்தேன்னா என்னால் எப்போ ஸ்டாப் பண்ண முடியும்? வாட்ஸ் த ஃபாஸ்டஸ்ட் வே? ஃப்ளைட். ஸோ 6 o'clock டிசைட் பண்ணனா நீங்கள் ஒரு ஈவினிங் 6 o'clock வந்து டிசைட் பண்ணுறோம்னா திருச்சி மட்டும் தான் நான் வந்து தஞ்சாவூர் ரீச் பண்ண முடியும். ஸோ ஃப்ளைட்ஸ் இருக்குமா? டொமஸ்டிக் ஃப்ளைட்ஸ் வந்து நிறைய இருக்குமா? இருக்காது. ஸோ அது அன்எக்ஸ்பிளைன். உங்க லைஃப் டைம்ல நீங்க வந்து மீட் பண்ண ப்ராப்ளம் வச்சு தான் எக்ஸ்பிளைன் பண்ணுறேன். நெக்ஸ்ட் அடுத்த ஆப்ஷன், நீங்க உங்க லைஃப் அந்த ஸ்கேர்ல போகுது. அடுத்த ஆப்ஷன் என்ன வச்சுக்கீங்க? ரோட் பேஸ்ல போகுது கார். ஸோ ஒரு கார் ஹையர் பண்ணுவீங்க. டிரான்ஸ்போர்டேஷன் காஸ்ட் வந்து அஃபோர்டபுளா இருக்குமா? உங்களுக்காக நீங்க மட்டும் சென்னையில இருந்து தஞ்சாவூர் வரணும்னா ஒரு கார் ஹையர் பண்றீங்கன்னா டிரான்ஸ்போர்ட்டபுளா அஃபோர்டபுளா இருக்குமா? யாரும் வருவாங்க? இப்போ வந்து தஞ்சாவூர் போற கார் வரும், சென்னையில இருந்து தஞ்சாவூர் வருவாங்க, டிரைவர் கூப்பிட்டு வந்தாங்கன்னா திருப்பி தஞ்சாவூர் டு சென்னை போறதுக்கு உங்க தான் காசு இருக்கும். கரெக்டா? ஸோ அது கண்டிப்பா அஃபோர்டபுளாவும் இருக்காது. நிறைய பேர் ஒரு ஃபெயிலியர் பண்ணுறது. திரும்பி வந்து நீங்க எப்படி தான் வரணும்? can't be make sure that there is another passenger will be there from Tanjavur to Chennai, right? What's another option? Train. இது ஒண்ணு போலாம். ட்ரெயின். ஓகேவா? நீங்க சொல்றதுக்கு நம்ம பண்ணலாம். வெயிட் பண்ணுங்க. ட்ரெயின். சோ ட்ரெயின்ல வந்து ரிசர்வேஷன் பண்ணாம உங்களால டிராவல் பண்ண முடியுமா? அன்ரிசர்வ்ல தான் டிராவல் பண்ணணும். அது வந்து ஈஸியா நம்ம சீட் கிடைக்குமா? கிடைக்காது. வேற பஸ். ஓகே, நெக்ஸ்ட் இப்போ ரிசர்வேஷன் அது ஒரு ப்ராப்ளம். ஃபாஸ்டா டிராவல் பண்ண முடியுமா? முடியாது. இப்போ ஒரு பெரிய இன்ஃப்ராஸ்ட்ரக்சரை மேக் பண்ணாமே ஒரு பெருசா ஒரு வந்து ஒரு ஃபிளைட் வந்து இது பண்ணணும்னா நிறைய ரெகுலேஷன்ஸ் போகணும், நிறைய ஏர்லைன்ஸ் தேவை. செகண்ட் ஒன்று என்ன? ஏர்போர்ட்ஸ் தேவை. இப்போ தஞ்சாவூர் ஏர்போர்ட்ல திருச்சி மட்டும் நம்ம நிறைய டிஸ்ட்ரிக்ட்ஸ் ஏர்போர்ட்ஸ் வரும். ஸோ இன்ஃப்ராஸ்ட்ரக்சருக்காக நிறைய இன்வெஸ்ட்மெண்ட் பண்ணணும். ஆனா ஹைப்பர் லூப்னு ஒரு கான்செப்ட் இருக்கு. நிறைய இன்ஃப்ராஸ்ட்ரக்சருக்காக இன்வெஸ்ட் பண்ணாம எப்படி வந்து இந்த ப்ராப்ளமை சால்வ் பண்ண முடியும்? அதுதான் ஹைப்பர் லூப். ஓகே, ஸோ வந்து இப்போ நம்ம எல்லாருமே இப்போ இந்த ப்ராப்ளமை சால்வ் பண்ணணும். நீங்க ஹைப்பர் லூப் கான்செப்ட் நான் சொல்லவே இல்லை, சொல்ல போனேன். இதுக்கு முன்னாடி இருக்கு உங்க பிரெயின் எப்படிலாம் யோசிச்சு என்ன பண்ணுவோம்? பஸ் இல்லைன்னா கார், அப்படின்னா ட்ரெயின், அப்படி இல்லைன்னா ஃபிளைட். அதனால உங்களுக்கு ஹெலிகாப்டர் விடலாம். ஏன் அது ஒரு பெஸ்ட் ஆஃப் ஹெலிகாப்டர் விடலாம். ஆனா வந்து காஸ்ட் எஃபிஷியன்டா we won't have customers. கஸ்டமர் வேணும். ஃபிளைட்ல போட்டு நம்ம வெளியே கஸ்டமர்ஸ் இல்லை. கரெக்டா? நம்ம கஸ்டமர்ஸ் வந்து நம்ம ஒரு இந்தியா ஒரு டெவலப்பிங் கண்ட்ரி, இந்த மாதிரியான கண்ட்ரியில ஒரு ஃபீஸபிள் ஒரு எக்கனாமிக்கலா ஒரு டிரான்ஸ்போர்டேஷனை ஃபாஸ்டா கொடுக்குறது ஒரு சேனல். நீங்க சொன்ன ஹெலிகாப்டர் விடலாம், சும்மா பேச்சு சொல்லலாம். ஆனா ப்ராக்டிகல் யோசிச்சு பாருங்க, முடியுமா? அதுக்கு ஒரு பைலட் போடணும், அதுக்கு ஒரு ட்ரெயின்டு பைலட் தேவை, ரெகுலேஷன்ஸ் எல்லாம் பாஸ் பண்ணணும், சேஃப்டி இருக்கணும். ஓகேவா? அதுக்கெல்லாம் நீங்க ஒரு கஸ்டமர் பிடிக்கணும். எத்தனை கஸ்டமர் வருவாங்க? நம்ம வந்து ஒரு ப்ராக்டிகலி யோசிச்சு பார்ப்போம். முடியுமா? முடியாது. கரெக்டா? இப்போ நம்ம அவுட் ஆஃப் த பாக்ஸ் யோசிக்கணும். இப்போ இதான் பிரச்சனை. இந்த பிரச்சனையை சால்வ் பண்றதுன்னா அவுட் ஆஃப் பாக்ஸ்ல ஒரு நியூ டிரான்ஸ்போர்டேஷன் சிஸ்டம் வரும். அதுதான் ஹைப்பர் லூப். ஓகே, லூப் அப்படின்னா ரிப்பீட்டிங். ஓகே, அதாவது ஒரு கோட்டுக்குள்ளேயே சிக்கிட்டாங்க. கரெக்டா? ஸோ ஒரு பைப் லைனை வந்து பாயிண்ட் ஏல இருந்து பாயிண்ட் பிக்கு வந்து கன்ஸ்ட்ரக்ட் பண்ணிட்டு, இப்போ ஒரு கார் வந்து ஒரு அட்மாஸ்பியர், அந்த கார் வந்து இங்க மூவ் ஆகுதுன்னு வச்சுக்கோங்க. எங்க மூவ் ஆகும்? வெயிட் மூவ் ஆகும். அட்மாஸ்பியர்ல தானே காற்று கிழிச்சிட்டு தானே போகுது. ஸோ காற்று கிழிச்சிட்டு போகும்போது என்ன ஆகும்? காற்று வந்து என்ன பண்ணும்? இல்ல பின்னால தள்ளும், டிராக் இருக்கும். கரெக்டா? ஒரு ஏர்கிராஃப்ட் வந்து என்வரான்மெண்ட்ல பறக்கும் போதும், ஒரு கார் வந்து என்வரான்மெண்ட்ல போகும்போதும், ஒரு ட்ரெயின் வந்து ஒரு என்வரான்மெண்ட்ல போகும்போது என்ன நடக்கும்? டிராக் அதிகமா இருக்கும். அதை குறைக்கிறதுக்காக என்ன பண்றாங்கன்னா ஒரு எலக்ட்ரிசிட்டிலேயே ரன் ஆகக்கூடிய ஒரு வெஹிக்கல், அது வந்து பாத்தீங்கன்னா ஒரு பைப்புல இருக்கும். ஸோ அது வந்து வேக்யூம் டென்சிட்டி வந்து இருக்காது, வேக்யூம் தான் இருக்கும். அந்த வேக்யூம் சேம்பர்ல ஒரு பாயிண்ட் ஏழு பாயிண்ட் பிக்கு ரொம்ப பாசிட்டிவ் ஆகும். ஸோ எலக்ட்ரிசிட்டியில தான் அது ஒர்க் ஆகும் போகுது. ஸோ நம்ம ரொம்ப சஸ்டைனபிளா டிசைன் பண்ணணும். நல்ல அதனால அது எனர்ஜி எஃபிஷியன்டா இருக்கும். ஓகேவா? ஃபிளைட்ல போனோம், செக்இன் இந்த 2 மணி நேரத்துக்கு முன்னாடி வரணும், வந்து அவ்வளவு நேரம் வெயிட் பண்ணணும். அதுக்கு செக்யூரிட்டி ப்ரோட்டோகாலையும் ஃபாலோ பண்ணி அப்புறமா ஃபிளைட்ல கூட ஒரு நெகட்டிவிட்டி இருக்கு. ரெண்டாவது வந்து நம்ம ஃபிளைட்ல டிராவல் பண்ண டைம் வந்து நம்ம செக்இன் ப்ராசஸ் ரொம்ப அதிகமாக ஸ்பெண்ட் பண்ணணும். அதெல்லாம் இதுல புரியும். ரெண்டாவது பெரிய இன்ஃப்ராஸ்ட்ரக்சர் தேவையில்ல. எல்லா இடத்துலயும் ஏர்போர்ட் போனா பெருசா ரன்வே இருக்கணும்,
ஏடிசி இருக்கணும், ஸ்கில்டு பர்சன்ஸ் இருக்கணும், கரெக்டா? அது எல்லாமே இதுல இருக்கும். ஸோ சிம்பிளா சொல்லணும்னா ஒரு பைப்புக்குள்ள பஸ் ஓட்டுற மாதிரி, அந்த பைப்புக்குள்ள என்ன இருக்காங்கன்னா காத்து இருக்காது. அதுல இப்போ ரொம்ப வேகமா பேசா டிராக் ரொம்ப கம்மியா இருக்கும். ரெண்டாவது வந்து எலக்ட்ரிக் ட்ரெயின் மாதிரி. ஸோ நம்ம ஃபியூல் போகலாம், எலக்ட்ரிசிட்டிலே ட்ரெயின் ஓட்டலாம், ஆனா ஒரு டியூபுக்குள்ள. அதுதான் அந்த இன்ஃப்ராஸ்ட்ரக்சர். ஸோ இப்போ பாருங்க, ஃபிளைட்ல போயிட்டு என்ன பண்ணிடுவாங்க, பைப்புக்கு போட்டுச்சுன்னா என்ன பண்ணிடுவாங்க, ஏர்போர்ட்டுக்கு வந்துடுவாங்க. ஆனா ஃபிளைட்ல போறது ரொம்ப கம்மியான ஸ்பெண்டிங்ல, பஸ்ல போற ஸ்பெண்டிங் ஐடியா இப்படிதான் வரும். சொல்ல புரியுங்களா? ஸோ யூ திங்க் அவுட் ஆஃப் த பாக்ஸ். இதுதான் இந்த ப்ராஜெக்ட். ஆனா இதை இம்ப்ளிமெண்ட் பண்றதுல நிறைய சேலஞ்ச் இருக்கு. இது யாருமே பண்ணாத ஒரு விஷயம், ஒரு ஐடியா தான். ஐடியேஷனை ப்ராசஸா மேக் பண்றதுக்கு ஸோ நம்ம ஒரு எக்ஸ்பெரிமெண்ட் பண்ணணும், கரெக்டா? ஸோ இது வந்து நம்ம பண்ணி பார்த்தாதான் என்னென்ன சேலஞ்சஸ் இருக்குன்னு தெரியும். அங்கதான் சிமுலேஷன் போய் வருது. ஒரு 8 years கிரவுண்ட் ரிசர்ச்சர் சார் வந்து ஒரு நியூ ப்ராடக்ட ஒரு சொசைட்டிக்கு நம்ம கொடுக்க போறோம்னா மல்டிபிள் டைரக்ஷன்ல வந்து பார்த்தீங்கன்னா சேலஞ்சஸ் இருக்கு. அந்த சேலஞ்ச் அட்ரஸ் பண்ணதான் R&D பண்றாங்க. அதை வந்து நம்ம எக்ஸ்பெரிமெண்ட்ல காஸ்ட் நம்ம ரெடியூஸ் பண்ணும்போது சீப்பான ஒரு அஃபோர்டபுளான ஒரு பிரைசிங்ல சொசைட்டிக்கு நம்ம தர முடியும். அங்கதான் சிமுலேஷன் பேஸ் இருக்கு. புரியுதுங்களா? சார் தான் பார்த்தீங்கன்னா சிமுலேஷன் டூல்ஸ் யூஸ் பண்ணி தான் வந்து அவரோட ஸ்டார்ட் அப்ஸ் எல்லாத்துக்குமே சிமுலேஷன் டூல்ஸ் யூஸ் பண்றாங்க. ஃபாஸ்டா மார்க்கெட்டுக்கு வர முடியும். 10 years ஆல்ரெடி ஒரு ரிசர்ச் 3 yearsல முடிச்சிருக்கோம். ரொம்ப ஷார்ட் டைம் பீரியட்ல உங்களால ப்ரோட்டோடைப் பண்ண முடியும். ப்ரூஃப் ஆஃப் கான்செப்ட் ஈஸியா ரெடி பண்ண முடியும். புரியுதுங்களா? ஸோ இதுதான் வந்து பாத்தீங்கன்னா கான்செப்ட். ஸோ ஒரு ப்ராப்ளம் இருக்குன்னா அந்த ப்ராப்ளம்க்கான சொல்யூஷன் வந்து நம்ம வந்து அவுட் ஆஃப் பாக்ஸ்ல எதனா ஒரு டெக்னாலஜி யூஸ் பண்ணி அவுட் ஆஃப் பாக்ஸ்ல திங்க் பண்ணணும். அவ்வளவுதான். ஓகே, எனக்கு ரொம்ப பிடிச்ச ஒரு எக்ஸாம்பிள் அதோட. ஸோ எல்லாரும் பென்சில் யூஸ் பண்ணிருக்கீங்களா? ஓகேவா? ஸோ நான் எப்பவுமே ஒரு இனோவேஷன் அப்படின்னு பேசும்போது எனக்கு ரொம்ப பிடிச்ச இனோவேஷன் தான் பென்சில் தான். பென்சிலோட ஷேப் என்ன? பென்டகன். வெரி குட். பென்டகன் பிரிசம், ரைட்? பென்சிலோட ஷேப் பென்டகன் பிரிசம். ஏன் வந்து பென்சில் வந்து சிலிண்ட்ரிக்கலா இல்ல? இல்ல, பென்சில் வந்து சிலிண்ட்ரிக்கலா இருக்கு. நம்ம பென்சிலா சிலிண்ட்ரிக்கலா தான் இருக்கு. நல்லா கிரிப் இருக்கும், நல்லா எழுத முடியும். பட் இருந்தாலும் பென்டகனா ஏன் இருக்கு? டேபிள் இருக்கும்போது உருண்டு விடாம இருக்கு. ஓகேவா? இதுதான் ப்ராப்ளம் சொல்றேன். ஆனா பென்டகன் தான் பெஸ்ட் ஷேப் அப்படிங்கிறது. ஏன் அது பெஸ்ட் ஷேப்? ஃபிரிக்ஷனை இன்க்ரீஸ் பண்ணும். ஸோ பென்சில் வந்து கீழே விழாது. இதுதான் கான்செப்ட். ஜெனரலா நீங்க காமன் சென்ஸ் யூஸ் பண்ணா பென்டகன் கீழே விழா சொல்லலாம். என்னன்றது பிசிக்ஸ் யூஸ் பண்ணா ஃபிரிக்ஷன் இன்க்ரீஸ் ஆகும், அதனால கீழே விழாது. ஸோ பென்டகன் தான் பெஸ்ட் ஷேப், பெஸ்ட் டிசைன். கீழே உருண்டு விடாம இருக்குதுன்றது எப்படி ஜட்ஜ் பண்ணுவோம்னா சிமுலேஷன் யூஸ் பண்ணுவோம். ஸோ ஒரு பென்சிலை ஈஸியாக பண்ணிடலாம். ஒரு ஆர்ட் ஒரு ஐபிஎல் பதிக்கல நம்மளோட காமன்ஸ் இமேஜினேஷன்லேயே நம்மளால டெஸ்ட் பண்ண முடியும். அங்கதான் சிமுலேஷன் எக்ஸ்பெரிமெண்ட் தேவைப்படுது. ஸோ எக்ஸ்பெரிமெண்ட் ரொம்ப ஃபாஸ்ட் ஆகும் உங்களோட ஐடியாவேஷன் டெஸ்ட் பண்ண. அங்கே சிமுலேஷன் பேஸ் இருக்கு. புரியுதுங்களா? ஸோ ஒன்ஸ் யூ ஐடென்டிஃபை தி ப்ராப்ளம், கம்ப்ளீட் அண்டர்ஸ்டாண்ட் பண்ணிட்டீங்கனாலே போதும். ப்ராப்ளம் சால்வ். ஸோ தட்ஸ் தி ஃபர்ஸ்ட் ஸ்டெப். ஓகே, anything to add, sir?
So சார் சொன்ன கேள்வி கேட்கலாமா? ஓகே, சரி. ஸ்டார்ட் அப்ல இல்லை, இப்போ சார் ஸ்டார்ட் அப் பற்றி சொல்லுவாங்க. சார் ஸ்டார்ட் அப்ல அவங்க என்ன பண்ணுவாங்க? சார் என்ன ஸ்டார்ட் அப் பற்றி பேசுறாங்க? இப்போ உங்களோட கான்செப்ட் பற்றி சார் சொன்னாங்க. இப்போ செஷன் வந்து இல்லை சார், சக்கரவர்த்தி சார் அவங்க வந்து இபிஎன் கம்பெனி சொல்லுவாங்க. அதில் எதை பற்றி பேசுனாங்க? ஸோ பிடிஓஎல்ஸ், அர்பன் ஏர் மொபிலிட்டி பற்றி பேசுனாங்க. அதை அவங்க எப்படி டிசைன் பண்ணியிருப்பாங்க, அதில் என்ன பிரச்சனை இருக்காதுல, ட்ரோனாவும் ஆப்ரேட் பண்ணணும், அப்புறம் ஃபிக்ஸ்ட் விங்காக பண்ணணும். கரெக்டா? ஃபிக்ஸ்ட் விங்காக பண்ணணும்னா அவங்களுக்கு என்னென்ன பிரச்சனை வந்துருக்கும்? அந்த லிஃப்டிங் லைன் அவங்க கால்குலேட் பண்ணணும், சரியா? அந்த விங் டிசைன் பண்ணணும். விங் டிசைன் பண்ணுறப்ப டோட்டலாக அந்த லிஃப்ட், அந்த ஒவ்வொரு ஏரோஃபாயிலுக்கு தகுந்த மாதிரி எவ்வளோ லிஃப்ட் ஜென்ரேட் ஆகும் அது எல்லாத்தையும் அவங்க பண்ணணும். கரெக்டா? அப்புறம் ஃபியூசலேஜோட ஆப்டிமைசேஷன் பண்ணணும். வெர்டிகல் ஹரிசாண்டல் ஸ்டெபிலைசர் ரிலேட்டட் திங்ஸ், அந்த ஸ்டெபிலிட்டி ரிலேட்டட் எல்லாமே பண்ணுவோம். அட் த சேம் டைம் அந்த வெயிட் வந்து லைக் விடிஓலேருந்து ஃபிக்ஸ்டிங்காக மாறி அது ஃப்ளை பண்ணணும். அந்த இடத்துல இருக்கிற எல்லா எக்ஸ்பெரிமெண்ட்டும் அப்ளை பண்ணுவோம். ஒரு யூனிட்ஸ்லாம் அப்ளை பண்ணுறாங்க, அதை சால்வ் பண்ணுறாங்க. இது எல்லாத்தையும் முன்னாடி விக்டர் எல்லாம் வச்சு பண்ணிட்டு இருந்தாங்க, சரியா? அதை வந்து என்ன பண்ணுவாங்கன்னா சிமுலேஷன் மூலியமா அதை வந்து அந்த என்விரான்மெண்ட்டை ரீக்ரியேட் பண்ணுவாங்க சாஃப்ட்வேர்ல. ஏரோடைனமிக்ஸ்ல, ஸ்ட்ரக்சர்ஸ்ல ஃபர்ஸ்ட் ஏரோடைனமிக்ஸ் வச்சு நம்ம ஒரு கன்செப்ஷுவல் டிசைனுக்கு அரையணும். கன்செப்ஷுவல் டிசைன் என்னன்னா இதே மாதிரி கேட்டகரி ஏர்கிராஃப்ட்ஸ் என்னென்ன இருக்குது,
இது எல்லாம் எந்த மாதிரி ஒரு விஷயங்களை சொல்லியிருக்கு, அவங்களோட ப்ளஸ் மைனஸ் என்ன, அதோட அட்வான்டேஜ் டிஸ்அட்வான்டேஜ் என்னன்னு arrive to a conceptual design. After the conceptual design, we will go for a preliminary. The preliminary design தான் the detailed design analysis வரும். நீங்க experimental analysis பண்ணுவீங்க, அந்த மெட்டீரியல் என்னங்கிறத டெஸ்ட் பண்ணுவீங்க, சாம்பிள் எடுத்து அதுக்கப்புறமே அதோட ஷேப் போகும், அதுக்கப்புறம் அந்த டென்சைல்லாம் அந்த மாதிரி இருக்கான்னு பிரேக் டெஸ்ட்லாம் பண்ணி பார்ப்பாங்க. போயிங் ஏர்பஸ்லாம் ரியல் டைம் ஏர்கிராஃப்ட் இருக்குல்ல, பண்ணி முடிச்சுட்டு விங் லோடிங் டெஸ்ட் எடுப்பாங்க. விங் லோடிங் என்னன்னா அந்த லிஃப்ட் ஜெனரேட் பண்ணது இல்லையா ஒரு ஏரோப்ளேன், அப்போ ஏர்கிராஃப்டோட விங் ஃபுல்லா அந்த லிஃப்ட் ஜெனரேட் பண்ணுது. விச் மீன்ஸ் அது ஏரோப்ளேன் கட்டி தூக்குது, அதான் உண்மை. அந்த ஏரோப்ளேன் தூக்குது, நடுவில் இருக்கப்ப அந்த வெயிட் இருக்கு, பிளஸ் அந்த தூக்குறப்ப அந்த ஸ்ட்ரக்சரல் லோட்ஸ் எல்லாம் அதில் ஆட் ஆகுதுல்ல, இப்போ ஆட்டோமேட்டிக்காக விங் பெண்ட் ஆகும். விங் பெண்டிங் அந்த இதை டெஸ்ட் பண்ணுறதுக்கு என்ன பண்ணுவாங்கன்னா ரியல் டைமா அந்த சினாரியோ அந்த விஷயத்த வந்து எக்ஸ்பெரிமெண்ட்ல சினாரியோ ஜெனரேட் பண்ணி பார்ப்பான். அந்த ரியல் ஏர்கிராஃப்டை வச்சு ஹைட்ராலிக் ஜாக்ஸ் நியூமேட்டிக் இதெல்லாம் வச்சு அதை வந்து ஸ்ட்ரக்சரல் லோட்லாம் கொடுத்து பார்ப்பாங்க. அப்போ அந்த விங்கை டோட்டலாக பெல்ட் பண்ணுவாங்க. எவ்வளோ பெரிய ஏர்கிராஃப்டோட விங்கை பெல்ட் பண்ணி எது வரைக்கும் பண்ணுவாங்கன்னா அதுக்கு ஸ்ட்ரக்சரல் டேமேஜ் ஆகும், அந்த விங் உடையிற வரைக்கும் பெல்ட் பண்ணுவாங்க. ஸோ இந்த மாதிரி அனாலிசிஸ் எல்லாம் மேனுஃபேக்சரிங் அப்போ டெஸ்டிங்ல போயிட்டு தான் இருக்கு. அட் த சேம் டைம் அது வர்றதுக்கு முன்னாடி இந்த ப்ரிலிமினரி இந்த டீட்டெயில் முடிக்கணும். இப்போ நான் சொன்ன டெஸ்டிங்லாம் வந்து டீட்டெயிலில் வரும். இந்த ப்ரிலிமினரி முடியணும், அவங்க அந்த சிஸ்டம்க்கு வந்து அவங்க ட்ரை பண்ணணும்னா இந்த கன்செப்சுவல் டு அதுக்கு அடுத்த ஸ்டேஜ் போகிறப்ப ப்ரிலிமினரி இஸ் வெரி இம்பார்ட்டன்ட் ஈவன் ஃபார் கன்செப்சுவல் டிசைன். ஸோ கன்செப்சுவல் சைசிங் அண்ட் பேசிக் கால்குலேஷன் ஆஃப் த லிஃப்ட் அண்ட் காம்பனன்ட் ரிலேட்டட் சைசிங் தான் ஒவ்வொரு காம்பனன்ட் ஒரு ஸ்க்ரூ போல்ட்லேருந்து ஒரு காம்பனன்ட் எங்கே வரப்போகுது, அதோட வெயிட் எப்படி ஆக்ட் ஆக போகுது, ஓவரால் ஃபோர்ஸஸ் எப்படி ரிலே ஆக போகுது, இது எல்லாம் கன்செப்ஷன் வரும். அடுத்து ப்ரீலிமினரியில் இவோல்வ் ஃபார் அனாலிசிஸ் லைக் ஏரோடைனமிக் ஸ்ட்ரக்சர்ஸ் அண்ட் ரிலேட்டட் அனாலிசிஸ். ஆஃப்டர் தட் லைக் ப்ரொபல்ஷன் சிஸ்டம் செலெக்ஷன்லாம் நடுவில் வந்துடும். ப்ரொபல்ஷன் சிஸ்டம் செலெக்ஷனை பற்றி தான் வந்து நம்ம உமாமகேஸ்வர் சார் பேசியிருந்தாங்க காலையில். அவங்க சொல்கிறப்ப ஒரு செஷனில் அடுத்து 8 சீட்டருக்கு வந்து அவங்களும் சார்பாக எலக்ட்ரிக் ஏர்கிராஃப்ட் இன்ஜின் எப்படி பண்ண போகிறாங்க, சேஃப் இன்ஜினியரிங் ஒர்க் பண்ணிட்டு இருக்காங்க, இதெல்லாம். ஸோ இந்த கன்செப்சுவல் லைக் ப்ரிலிமினரி ப்ரோக்ராம் அது முடிஞ்சதுக்கப்புறம் டீடைல் இருக்கும். அந்த டீடைல் டிசைனில் தான் இது கம்ப்ளீட் ஆல் தோஸ் வாட் எவர் யூ ஹவ் அனலைஸ் அண்ட் அகைன் யூ வில் டெஸ்ட் தி சேம் என்விரான்மெண்ட், மேக் இட் அண்ட் பிரேக் இட் அண்ட் ஃப்ளை இட் அண்ட் யூ வில் கிளைம். அந்த ஒவ்வொரு ரெகுலேஷன்ஸ் லைக் நார்ம்ஸ் இருக்கு. இன்னைக்கு எஸ்ஆர் சக்கரவர்த்தி சார் சொன்னார்ல ரெகுலேஷன், ட்ரோனுக்கு ஒரு ரெகுலேஷன் இருக்கு. அந்த ஏர் மீடியம்ல ட்ரோன் ஒரு மீடியம்ல இருக்கு. யூஏஎம் அர்பன் ஏர் மொபிலிட்டின்னு சொல்றோம். இந்த அர்பன் ஏர் மொபிலிட்டி இப்போ அட்வான்ஸ்டு ஏர் மொபிலிட்டி ஆயிடுச்சு ஏஎம்ஆ. அதுக்கு ஒரு மீடியம் ஹைட்ஸ் இருக்கு, அதுக்கு மேல ஏவியேஷன் ஒன்று இருக்கு. அந்த ஃபிளையிங் ஹைட் லேண்டிங் ஹைட் தான். இப்போ வந்து ட்ரோனும் ஏஎம்மும் ஒரு இடத்துல இன்ட்ராக்ட் ஆகுது. அதே மாதிரி அர்பன் ஏர் மொபிலிட்டியோட பீக் ஹைட்டும் ஏர்கிராஃப்டும் ஒரு இடத்துல இன்டர்ஃபிக் ஆகுது அப்படிங்கிறத தெளிவாக சொன்னாரு. அவர் லேண்ட் ஆகிறப்ப எப்படி ட்ரோன்ஸ் அந்த இடத்துக்கு வரக்கூடாது, அந்த ரீசன் எப்படி ரெட் ஜோனா பண்ணலாம்னு நாங்கள் ஐடியா கொடுத்தோம். ஏன்னா அவங்க தான் ஃபர்ஸ்ட் இப்போ டிஜிசியோட ரெகுலேஷன்ஸ்லாம் ஒர்க் பண்ணிட்டு இருக்காங்க. மேம் சொன்னா 26 கேட்டிருந்தாங்க. இப்போ இன்னும் ஒரு தள்ளி போக கூட வாய்ப்பு இருக்கும் போது. சார் பெங்களூர்ல கூட லாஸ்ட் பேக் பிரசன்டட் லாஸ்ட் தட் பெங்களூர்ல லான்ச் பண்ணாங்க. So I think the work is going on. It is going in a very good way. But regulations தான் இங்க ரொம்ப ஸ்ட்ரிஞ்சென்ட்டா இருக்கு. Is facing trouble in that area. It will be there. ஏன்னா இப்போ ஆர்ச்சர்னு ஒரு US based aircraft manufacturer அவங்க 4 வருஷத்துக்கு முன்னாடி தான் ஆரம்பிச்சாங்க. ஆர்ச்சர் 4 வருஷத்துக்கு முன்னாடி அப்படி ஒரு கம்பெனியே கிடையாது. இங்க நம்ம HCL தான் வந்து they have done autonomous thing for them. கேள்விப்பட்டிருக்கீங்களா? ஆர்ச்சர்ங்கிற கம்பெனி என்னன்னா வீட்டு ஏர்கிராஃப்ட் 4 சீட்டர் ஏர்கிராஃப்ட். இண்டிகோ எத்தனை பேர் தெரியும்? இண்டிகோ ஏர்லைன்ஸ் இண்டோமர் தெரியுமா? தெரியாதா? இண்டோமர் தான் இண்டிகோ. இண்டோமர் வந்து 200 ஏர்கிராஃப்ட் அவங்கள்ட்ட வாங்கியிருக்காங்க ஆர்ச்சர் பேர் வீடியோ. அவங்க ஆப்ரேஷன்ஸே 26ல ஆரம்பிக்க போறாங்க. ஏர் டாக்ஸி ஆப்ரேஷன்ஸ் இந்தியாவில் ஆரம்பிக்கிறதுக்கு சார் காட்டினாங்கன்னா அப்படி அந்த ரெகுலேஷன்ஸ் எல்லாமே FAA-யோட certification process முடிய போகுது. அவங்க ஆல்மோஸ்ட் டன். வித்தின் few years சொல்லுவாங்க இருக்கவங்க. நம்ம வந்து அது வந்து வேர்ல்டு மற்ற இடத்துல இந்த அர்பன் ஏர் மொபிலிட்டியா இருக்கும், லைக் அட்வான்ஸ் advanced air mobility, V2 aircraft, eVTOLs, now Parakava we are going to witness. In 26, definitely we are going to see eVTOLs flying in the sky in the world. Especially even India already has orders. 200 aircraft we have ordered. That's why like we are, the thing is that as the US startup again, Indian startup should come up. Indian startup, I think our case, we are speaking about the startup for last 2 days, and our sessions are focused towards it. We have a lot of internal, again, policy matters to be reformed. This year, in government of India have waived up the investors' income tax for startups. If an investor puts in money, startup should pay some income tax for that, but other waiver for that. Other than that, many things are there. One example is if an investor exiting that company, you need to pay 42% tax. So only because of this, many foreign investors are not coming, and that is also reason that over 60 crores, 70 crores funding on funding on so whenever it is no equal, right? So similarly, we are also feeling that okay, this is the gap. So it is best to start a startup in Singapore. But still, startup here and many initiatives are taken by our startup team, especially we have opened an office at Dubai last month for startup. So our startups we can pitch in various places. Karupandan sir சொல்றப்ப கூட he invented Vimana accelerator இங்க incubator இருக்கு. You will bring an idea into a prototype, into a product, and you will launch your product, and people will start to buy it. Correctா? People வந்து வாங்க ஆரம்பிச்சுவாங்க. அதோட ஸ்கேலிங் சைஸ்ல வரும். ஸ்கேலிங்னா you will expand the product development. So அந்த ஸ்டேஜ்ல இருக்கிறத வந்து ஆக்சிலரேட்டர் அது விமானம் அதுக்கு தான் அந்த ஏரோஸ்பேஸ் ஸ்பேஸ் ரிலேட்டட் ஸ்டார்ட்அப்ஸ் கொண்டு வந்தாங்க. Anyhow, this session was, I think, interaction went on today was very fruitful, and please follow their softwares, and they will be utilize them on the platforms you use பண்ணுங்க. Try to do analysis and work it out, and yes, through that you will get a great job opportunity. Many startups are using their softwares are used by them, and we are planning to use them. Answers are like more answers is used for every aircraft manufacturing startups. Student version, everything is available. Please utilize it. And thank you for the session. Thank you.
On behalf of the Institution of Engineers India, Tamil Nadu Center and IEEE and PMIS, it is my privilege to extend a heartfelt welcome to all our esteemed guests. Dr. N. Venkatachalapathy Sir is a distinguished leader and a chairman of IEI TNSC. With his vast experience and commitment to the engineering excellence, he has been a driving force in shaping the future of engineering education. We are honored to have you with us today, sir. May I now invite Dr. N. Venkatachalapathy Sir to address the gathering.
Long wait, the program starts. Respected the registrar, the list, Dr. Srividya, today's chief guest, Dr. Sanjay Kumar, the chairman, Seminar Technical Committee, Karnagaran, convener and committee member, IEI TNSC, and Muthumaran, organizing secretary, and
Engineering, D. Gokul, Honorary Secretary, IEI TNSC, the sponsors for this program, dignitaries, the immediate chairperson, Tanjavur Local Center, Dr. Mr. Jayakumar, Dr. Srimati, and dear participants, good evening to all of you. Really, after a wonderful 2 days seminar, really we have come to a valedictory function. It is really very happy moment for Tanjavur Institute of Engineers Local Center and Tamil Nadu State Center to conduct this program, that too in aerospace engineering Tier 2, Tier 3 cities. Really, it is a very great opportunity for you. Otherwise, for attending this type of seminars, you have to go to Chennai or Bangalore or bigger cities, mainly. Mechanical, electrical, normally we used to conduct many programs. But for this particular knowledge domain, definitely we have to go to big cities to attend this type of seminars. Really, we have to thank the PMIST for accepting to host this event at this campus, and the Institution of Engineers, TNSC, and the Tanjavur local chapter are very grateful for PMIST to have this program. And for the coming to my duty, really it is to welcome each one of you present here, and due to important function meeting, the district collector is not able to come. Otherwise, remaining all the dignitaries have come, and I welcome all the dignitaries to this valedictory function. Already it is we are delayed, so I don't want to invite welcome each one of you, but at the same time I welcome each one of you present here. Thank you very much.
Thank you, sir, for the warm welcome. Let's now embrace the journey ahead, where every moment will resonate with purpose and passion. It's my pleasure to invite Dr. M. Sindhu Kumar, sir, to share the seminar report.
Good evening. So I am here to give the report about the seminar, and we have conducted 2 days. So there is all India seminar on trends in aviation, civil and defense on 30 and 31st August 2024. So first of all, we would like to thank Institute of Engineers Tamil Nadu State Center for approving this all India seminar on trends in aviation, and the associated partners like IEEA, Periyar Maniam University, and also we have Institution of Engineers Tanjavur Local Center, and we have 2 partners like the Startup TN and the Platinum Aerospace Technologies Private Limited, and we have our platinum sponsor Altair, CATFM, and Infinity Arsenal Private Limited and ANSYS, and we have bronze sponsor Vimana Labs. So we would like to thank all the partner and sponsors for organizing this 2 days seminar on trends in aviation. And day 1 we had 4 sessions including the panel discussion, and today also we had 4 sessions including panel discussions with Karnagaran and Chakravarti sir. And about the seminar, so overall we have selected 26 papers for both paper and poster presentation. Out of 26, 50 contributors from the students and research scholars from 4 different institutions and 15 faculty. The different universities like Kumararu College of Technology, Periyar Maniam Institute of Science and Technology, and we had papers from Mahindra Engineering College and also from the Shastra University. So from these universities and institutions, we have received more than 26 papers, out of which we have selected 26 for paper and poster presentations. So from these 26, we also going to award 3 best paper and poster presentations at the end of this session. And on the outside, we would like to thank all the sponsors and the event coordinators, particularly for the PMIST for organizing and hosting this event at Tanjavur Local Center. Thank you.
Thank you, sir, for the insightful report. Please join me in welcoming Engineer C.S. Karnagaran, sir, convener and committee member of IEI TNSC, to the stage to deliver the felicitation address.
So good evening, one and all. I thank especially Srividya ma'am for providing this opportunity to and coming forward to host this event. First, engineering
Institutions of Engineers India, TNSC, Chairman, Secretary, and also National ASDB Chairman, Dr. Karthikeyan sir, Dr. Arvind Dambi, and Gokul sir, for approving the event on behalf of IEA, and then IEEE to coming forward and connecting with various speakers and the sponsors to bringing them here. It is very easy to organize such an event in 10 times or 20 times bigger way in a metropolitan city. But it is very, very tough to deliver such a standard event in a semi-urban or rural place. And that Periyar Mani may have supported, and the entire team of these two professional bodies have came together. And especially if you are doing this, you need greater support from the industry. That is where right from government policymakers to Tamil Nadu government to the level of aerospace industries have stood for this initiative. The very moment both Alter and ANSYS, they came forward and they said, no, we are very eager. This is the very first time we are doing in the history. Like nobody have done such an event in a semi-urban place, semi-urban or near to rural place. And this is the first time, and they supported that initiative. And next they are of course focusing over industrial initiatives similarly. And along with that, startups also came forward like Infinity Arsenals, Vimana. They tremendously came forward, and they have received a very good visibility across this event. Because this event is being witnessed not only here, through online across Indian Institution of Engineers state chapters, like every state, and also local chapters. Like Tamil Nadu alone has 17 local chapters, and IEEE is well connected with the aerospace industries and academicians, and also aerospace academic leaders and everyone knows about this event and they are following. And especially the ASDB chair who came here, he is actually head for entire state, entire local chapters of the country, and his outreach is also taken this event beyond boundaries through social networking. I should also mention our partners, Pune Aerospace Technologies, which have tremendously supportive in connecting the local vendors and local people and organizing the event here. Other than yesterday, we had even police station event outside. Like other than this, we had IEEE and IEA event was there, and also Startup TN. Startup TN was always supportive to IEEE, and they have we are planning to sign an MOU also next month. In that, their support in connecting policymakers, even they tried hard to connect with minister and to get them on board, but soon minister have accepted to promote this event again with the photos and the outcome of the event through his social media posts like Twitter and LinkedIn. But unfortunately, because of the CM's outstation trip, he couldn't be here. He need to be there in Chennai. So anyhow, this region have made a tremendous effort, and the effort have given a great report here as reported by Sindhu Kumar sir. With this, I thank everyone, especially Muthuraman sir for giving his toughest, hard effort in organizing such a big event here as an organizing secretary, and our HOD like Karthik Subramaniam sir being the department HOD, and the technical team committee member, he had given his a lot to this event, and main special people, Tanjavur local center people like Sunami ma'am and our Vengadagari sir and Sendamal sir. He couldn't join here today and yesterday, but he was very, very supportive, and the entire Tanjavur local center people supported right from the beginning, from the first day itself, and I'm seeing sir who's sitting in the center, Kannan sir, yeah. He was there in the very first meeting, and now also he is here, and he is witnessing how it evolved within 40 days or within 30 days, how big event can be done to a place like Tanjavur. So it is a great successful event, and that's what everyone, right from the speakers and the sponsor and whoever interacted here, they are conveying the wishes. I believe ma'am will accept. She traveled all the way from Salem to be here, and yesterday we had people from Thoothukudi, Tirunelveli, many places, and everyone conveyed their wishes even yesterday during the dinner. So thank you so much. Thank you, best wishes for this,
and this history and the legacy should continue. I believe this IEI Aero TNSC people on 17 local chapters with the support of IEEE and other industries will continue to deliver the excellence. Thank you.
Thank you, sir, for your brilliant presentation. It's my privilege to invite Dr. P.K. Srividya ma'am, Registrar Chemist, who has been guiding us through all our paths to deliver presidential address.
Respected guests on the days and off the days, and participants from various institutes and beloved students. Good evening, one and all. It's my pleasure to stand before you here for the valedictory function of 2 days all-day seminar of Institute of Engineers Tamil Nadu State Center in association with IEA, TMIST and Institute of Engineers and our local center. First of all, I thank Dr. Karnagran for giving us a wonderful opportunity to PMIST to host this institute, and also the Institute of Engineers local chapter. I thank them for giving the wonderful opportunity through which our students will be definitely benefited out of the 2 days on-year seminar. They have come across many, eminent speakers. They hear about lot of, more than the paper presentations, the eminent speakers have come over here so that it will boost the younger minds. So that they want to be in the next stage. They have to think, no, what is next? The topic is a very interesting topic, strengths in aviation, civil and defense. It is a need of the hour. So about the carry home message to my beloved students of all the institute is at least you could have taken one message from out of the 2 days on-year seminar that will turn your life into glorious. The standing example is my student below the birth is here, Vimana Lab CEO, Ms. Bharati. He is the standing example for all the aerospace students. I told you that. If the student is interested, means you can come over here just everybody they want to see. Proud alumni of previous Vimana Lab CEO. CEO or MD?
I'm CEO.
CEO. Yeah. Across the transformation period, is expecting from each and every individual. It speaks about the one student is the example. So my dear students, so the take home message is what you want to be the next future after your career of taking as aeronautical engineering, which sector you want to be excel in your career. So you have to set up accordingly, you have to set your goals. To the goals, what are all the things to achieve your goals, you have to think twice, thrice and self-evaluate yourself. That's the more important necessity, need of the other. See, many things now, nowadays the students, that is post-COVID, lot of challenges with the students, the student community side. Where our, that is the time, the Institute of Engineers and IST, like global chapters, the student chapter is there, well acting chapter is there. We do participate so many events now, everything is with the mobile, you don't have the passion towards attending the conference or sitting the conference, everything you can search it and you can find it out all those things. But deliberations, meeting the people and chatting with the people, then only you will get that is eye-opener for your future career. That's what we are all in our college days, we used to attend many seminars, conferences, presenting papers like that. So that after the COVID, no, so many parameters. There is the mobile addiction is the key parameter one way. The another way is the obviously so many things. The result there is history. You can go and search it from the Google what is happening in China now and Coimbatore 1 week before. So my beloved students, set your path. So it is a time to explore. There is India is having enough potential of younger minds. So channelize what Kalam told. 2030 is nearing, right? So we want to set up. So my aspiration to all my young budding engineers. So try to utilize the opportunity wherever possible and try to explore it and try to enjoy the campus life. in a safer manner and enjoy your future. That is, for the next 20 years, your life is a healthy and successful engineer's life. With this, I congratulate the organizers for arranging just such a wonderful all-India seminar, and our that is coordinator Uttaraman and Karthik Subramaniam and all the team members of this state chapter as well as local chapter for arranging a wonderful seminar. Thank you, thank you, thank you.
I now proudly invite Engineer R.K. Muthuraman sir, Organizing Secretary and Coordinator of IEI Previous Chapter, to honor sponsors and organizers of the event.
Good evening, one and all gathered here. On behalf of IEI TNSC, IEI Punjab Local Center, famous and IEEA, we would like to honor our sponsors first for the event, because this is the first event of aero industry of IEI ASDB board having more sponsors. First, we would like to call upon Catherine Manchis to receive memento from our respected registrar ma'am. I also welcome the dignitaries to join to honor our sponsors. Next, we would like to call upon team members from Infield Arsenal to receive the memento from our dignitaries. Next, we would like to call upon team members from MRS Private Limited to receive the memento from the dignitaries. Also, we would like to invite members from Civil and Aerospace Technologies to receive a memento from our dignitaries. Please give a round of applause for them. They are very much for the participation. Next, we like to honor our organizers. First, we like to call upon Dr. Government member organizing committee to receive a certificate of application and registration on our committee. Next, we would like to call upon Sumati ma'am from Punjab Local Center. Next, Jaykumar sir from Punjab Local Center. Next, our chairman receiving prize certificate and honor service certificate from our dignitaries. Next, I would like to call upon Kiran Kaushik, who is the backbone of conducting this event. Welcome to Kiran. Dr. Sanjay Kumar sir, Chairman Technical Committee, receiving appreciation certificate from Krishna ma'am. Next, we would like to call upon Pratik sir, Aerospace Engineering. Pratik sir from Aerospace Engineering, the organizing team members and technical team members from the Department of Aerospace Engineering. Next, Nagaraj sir, Ismail sir, and Ramani ma'am.
it's time to honor our chief guest. I request Honorable Secretary of IEI TNSC to honor our Krishanan. Thank you, ma'am, for the very great achievement. I request Karnaran sir to honor our IEI chairman of the Global Center. I request the Odisha ma'am to honor our Sanjeev sir with a memento. And second, I request Gopal sir to honor our HOD Aerospace Engineering, Mr. Kai Baksurunge. He is member of Punjab Global Center with a memento. So with this, we are going to add one more thing. We are going to appreciate the school students who attended the event conducted at the Government Girls High School Institute, Pattabadi, Tanjavur, Sustainable Development Goals, Role of Engineers in Achieving Carbon Neutrality. I will call upon Satya ma'am and their team members to collect the certificate from our dignitaries. Please give a round of applause for the school students. They have tremendously done something to the engineering community. Thank you so much. Thank you. Next, I will like to call upon Dr. Sanjeev Kumar sir, Chairman Technical Committee, to read out the names of winners. Please, sir.
Out of 26 paper and poster presentation, we have selected 4 papers for first 3 hours and 1 hour for the third prize and 2 papers for the second and 1 to first prize. And the third prize goes to Soumya from Mahendra Engineering College. And second prize goes to Mukesh Mutram Ji from Indian. And one more second prize goes to Mr. Arun Kumar M and Vivesh S from Master University. And the first prize goes to Akhilan B and Rajlakshmi X.
Now it's time to welcome the engineer P. Gopal sir, Honorary Secretary, IEI TNSC, to propose the word of.
So very good afternoon to all. Good afternoon. Malay Vanakkam. So very important, I think, the 2 days seminar. Maybe we started with yesterday, but we don't know, the time has gone very speed, and today we have come to the valedictory program. So the most honorable, the Registrar, P.K. Shividya Madam, Registrar of Periyar Maniammai Science and Technology, and also Dr. N. Venkatachalapathy sir, who is the chairman of IEI TNSC, and Dr. M. Senthil Kumar, who is the chairman of Seminar Degree Committee, and Muthuraman sir, and also our engineer Karunakaran sir and Karthik sir. So it's been immense pleasure that the seminar, whatever we have planned, I think it has gone, we can say, more than 100%, we can say 200% it was successful. So that is the work behind the team, which has been completely contributed to Tanjavur. See, Tanjavur, like it is something like a Chola period, right? Tanjavur, two things they will always say. One is like the architecture, what the Chola has done in 11th century. And it is the only one, I think it is giving a nice field. Tanjavur, like, and our Namakana Nel, Smani, Kurkavenda, Tanjavur, Suluan. So, such a beautiful, fertile land, what is being flourished, and the Kaveri is flowing into the Tanjavur. And we always say that today, I think the capital of city is Chennai. But almost something 100 years, 200 years before, the capital of Tamil Nadu is Tanjavur, because that is the empire they built up, and that is the gene is being there inside the Tanjavur people, and it's spread throughout the world, we can say. So such a proud moment of Tanjavur, I think today we are organizing. It's the 5th All India seminar, which is conducted by the Tamil Nadu State Center, under the leadership of Arude Nambi sir, as well as with the Aero Department Karnataka. So it is something like very heart-touching, we can say, because we have organized the program, one in Salem and another 2 in Chennai, and the upcoming is going to happen in Chennai again. But Salem and Chennai, something like we always say something around of urban state. But Tanjavur and Sola, Karnataka, I think he started talking like when he become an Aero member of our committee. From December onwards, he used to torture me because he will be calling and he will be discussing for more than an hour how I can plan an event for the convention, seminar, and workshops, and many more things. And we said, yes, definitely we can do, but you be the bylaw what IES follow. And definitely, I think now Karna would have understood what is the bylaw belongs to IEI, and it's something that's so fantastic because the organization which is having nearly 1 or 2 years, and it is holding the bylaw, and the only society which got Royal Charter of Society by the British people is none other than Institute of Engineers. So such a proud moment of IEA is having, and that is all we are being an IEA, we are very proud. The one example I could say, IEA, which means like the ISRO, the chairman, we know Somnath sir, everybody will tell, Yarak Somnath sir, theriyad. Because he is the man behind the Chandrayaan 3, and every ISRO launch you will be seeing in the television channel, and every day he try to say. Somebody doesn't know about Somnath sir, I think they are that much lagging on the science and technology, I can say. And after Somnath sir, this next person who is the apex cadre, we can always say is nothing but our the LPC director, Narayanan sir. So the Narayanan sir who is got the engineering and AME is given by the IEA. So he done his diploma and he don't want like get to the engineering graduate. He doesn't go to engineering college, but he got engineering certificate from the IEA. So we are proud that a person who is the top number 2 in the ISRO who got to become an engineer from IEA and is flourishing the complete nation is that is the power of IEA. We have so many people like that from IEA, and I think the student community, why we want to fetch up the Institute of Engineers, which means like you should know what is the connecting feature with academic and industry. There's so much of gap is to be filled up. Our IEA is doing that. That is one. Their seminar is being organized under the topic of trends in aviation, civil and defense. Definitely, the Institute of Engineering Tamil Nadu State Center, along with Institute of Aeronautics, Astronautics and Aviation, and Periyar Maniammai Institute of Science and Technology, Institute of Engineering, Tanjavur Local Center, has organized such a mega event in the place of Tanjavur and created a lot of wisdom. And 2 days, I think the knowledge, whatever you got it from so many speakers, it's something like very abundant. You cannot get it easily. Today, you had a speaker from GE. GE, I think, if you're in a dream, you cannot get into GE. Such a tough exam, what you can face in the GE is something like the face in your career is something GE, the General Electrics. Because I have one friend there, she used to say that it's not that easy that I can be able to spend my personal life very easy because GE is having so much of compact. And when you clear those exams and you become a regular employee, definitely I think you will be in the top notch of the not nation or the international world about the aviation as well as the aircraft. Such a potential, our Uma Maheshwaran sir has been addressed to you, and definitely his lecture, I think maybe we have to listen it up. And he said, 1947, when Wright brothers has incorporated the flight, we were all struggling for getting an independence.
Now almost with 75 independence today, we are very happy that we are going to create our own aviation sector and we are going to give a compliment to the entire world that India is going to be in our top 3. Such kind of a knowledge we have is given by the GE, the general manager. And second, you can always say, I think we got Professor Chakravarti sir. He's very close friend of mine and he's worked for ISRO so many projects and he is having so many startups. He is a person who belongs to Agnikul, he is doing E-plane and he is doing Hyperloop and he has addressed to you people, especially on the topic what really I think next world is going to take on the transportation. And so many speakers, what really they connected for you and address, it is all I think we cannot able to get it from the notebooks or to get it from the classroom. So such a eminent seminars or such a all India seminars which is organized with so many organizations and today you all got the opportunity and you got the very various wisdoms to happen it. Don't always think that we are from Tanjavur, we are something like rural background. அதெல்லாம் படிச்சு ஏரியாவுக்காக மட்டும் தான் இந்த செமினார் இங்க ஆர்கனைஸ் பண்ணது. இன்னமும் நீங்க எல்லாம் வந்து சென்னையில வந்து டிஃபரெண்ட் ஐஐடில இருக்காங்க, அண்ணாநிஸ் இருக்காங்க, எஸ்ஆர்எம் இருக்காங்க, விஐடி இருக்காங்க. தஞ்சாவூர், திருச்சி, மதுரை எல்லாம் வந்து ஏதோ ஒரு பெல்ட் நாம எல்லாம் இப்படியே தான் எடுத்துட்டு போனோம்னு வந்து நினைக்கவே நினைக்காதீங்க. அதுக்காக உடைக்கிறதுக்கு மட்டும் தான் இந்த செமினார் இங்கே ஆர்கனைஸ் பண்ணி உங்களுக்காக மட்டும் தான் இவ்வளவு பெரிய எமினன்ட் ஸ்பீக்கர்ஸ் we brought and given to you. So think for that, it is not for us, not for the registrar madam, not for the SODs or not for the Venezuela who is the dean of the central food industries and many people. It's only for you people. The young people of Aero department, really what you want to fetch up, you can do it. Yesterday we had a startup, Mr. Dr. Kalpanan has come. He said, I think whatever you have an idea, bring it to me. I will incorporate the government of Tamil Nadu. I can able to bring back the startup idea. So that is all very big opportunity you got it. Today, world is not so easy. It's always a challenging world, competitive world. If you are not in the race, somebody will come and eat and go you. And don't think that, okay, if I complete my engineering, I will go become like a Zomato or Swiggy or something else. It is not the question mark of engineers. Engineers is something like a genius, they say. Because it's not so easy. Engineers studying so many seminar subjects, so many assignments, so many practical sessions, and become an engineer is not just putting after my name. It is something you need to contribute for the nation, for the your institutions, for yourself. So be proud, and Aero is something so dynamic subject. Don't think that we don't have any placements, we need to go for higher study, not so. You would have seen whatever the presentation carried out yesterday, Pandian sir, yesterday so many speakers of the panel discussions, and today whoever given the lot of lectures and answers we have, all here we have, so many people wanted the young dynamic people to start the aviation department in the bigger way. It's not only the aviation, it's again the aerospace. But the rocket, we never thought that ISRO only can launch the rockets and satellites. Today, our own people, the Pawan, who is the CEO of the Skyroad, he resigned from ISRO, went into 2017, he started Skyroad. Today, he is giving compliment to ISRO, which means like he said, what ISRO has made the SSLV, I can also make my own launch vehicle, I can also launch it. See, that is the power of young people. I only want to say the importance of India. 1947, we got the independence, we doesn't have anything. The British people completely eroded everything and they gone, they left only 50 million people. They are all with a different religion, different caste, different food, different dress, different language, everything was so different. He said, I think these people, definitely they are going to fight each other and definitely we will come back to rule them because they are not going to be united. But we proved to the British people that we are all united and we are Indians. That is what people from Jammu and Kashmir to the Kanyakumari, whatever the people are different from Tamil Nadu to Jammu or Gujarat or Assam, we are all say as an Indian, we are unitedly, we are standing to reach the India to the top level. So such a potential we are having because the human assets. Today the human assets of India is something so bigger. Today we are ruling America. You know the vice president who have been in the last party of Biden, today she is contesting an Indian. She is the origin of India. And again the vice president of US, who is being the wife of the US vice president who is contesting, she is the origin of India. You see the UK president, prime minister who has been earlier, he is a person who is an Indian, who is a Narayana Murthy, his son-in-law. The Singapore prime minister is an Indian. The top notch of Microsoft, or you take Google, you take IBM, you take SL, everywhere Indians are placing in the top notch role. And another, we have only 22 years to reach our 100 years of independence. Definitely India is going to be the top 3 countries of the world. We are going to be economically top 3. We are going to technologically top 3. We are going to be in all the area financially, we are going to be top 3. The only one request I want to say, the youth, they always have a power, but being the topmost as technology, being topmost as economical, we are not going to be something like we achieved something big. We wanted our country to be a humanitarian base. We wanted our country to be happiest most. The happy sense like having 3 Hyundai, 3 Audi cars, or 4 ACs, or 10 bungalows, you cannot be able to generate happiness among you. You need to serve for the nation. You need to see the humanitarian base. Whatever technology I got it, it's going to be service for the people of India. Definitely you'll be happy. That's what Abdul Kalam says that. A girl asked one question to the Abdul Kalam, sir, what is the strongest and weakest point of our country? He said the strongest point of our country is youth like you. Because you are the people who is going to rule our country definitely, and you are going to bring a big change of it. And the weakest point, youth is not having a vision. That's the biggest point of that. So definitely you people have a vision, have a goal, keep building your career, have a sharpened skill set, definitely you can achieve a lot. So with this, let me complete my own, the job, whatever people have given me. So the most important, Dr. N. Venkateswara sir, I should thank him because he is the IEI Tanjavur Local Center. Almost he is having a busy schedule. Definitely, I think he has been with us for 2 days. And I think he always says so many people are calling him, so many committees he is a member. But eventually, when we say we are going to organize it, along with him, I should thank Jayakumar sir and Sumati madam because they are all past chairmen. Even the committee members, I don't know, maybe Kannan sir is there, but definitely all people are there for 2 days. I thank the complete Tanjavur Local Center for making this event successful. Thank you so much, sir. I also extend my thanks to Chetri Kumar sir. I think he has come from the Kumar Guru. He was there past 2 days and he has the activations, ignitions he has given for the complete technical committee. Today the people who own the prizes is something like appreciation we want to give it. But everybody is a winner who have participated. The 26 to 28 paper you have given, it is not that easy that you will be selecting your paper. Many papers would have come. He selected few papers and they have been given a chance to present a poster. From their top 3 we have given, but always we say the participation is something winner. And winning is again like something like you made something MR. And definitely we should thank Sanjeev Kumar sir. I think the day one the brochure was released, he is the person who continuously making this technical committee activated. And today I think he has come. He's completed this journey and definitely he has to submit one more report for us to send it to the headquarters. So thank you so much sir for being here. And I should thank Arude Nambi sir and the Rangnath sir. Both of them not there because Rangnath sir is the first Tamilian man who has become the president of IEA. He is the second person of Tamil Nadu. Eventually they become president of IEA is something so great. And he is the person who has given all the opportunities for us to make it up. And I also thank the Arude Nambi sir who has been there yesterday and he is again the chairman of Aero Board and he has given the complete support. The most extended, I should thank Sri Vidya Madam, who is a registrar of Periyar Maniam Science and Technology, along with the Vice Chancellor, because such a big environment, such a big auditorium, and the complete support of PMST, the HODs, faculty, students, for being there for past 2 days. Can we give an applause to the your own management that they given the support? Definitely, thank you so much, Madam. I think without your support, this cannot be happened. And the students of your institutions, past 2 days, they would have got a lot of nurtured knowledge. And definitely they will be taken up to the next level. Thank you so much. And we have our Muthuraman sir. So he is the part and parcel of a college, but being the support of IEEE and IEA, I think his role is so huge and he has activated completely about the seminar. And definitely without any words, I think we should thank him. And thank you so much sir for making this event successful. And I should thank all the students as well as the teachers and the IEA committee members and the sponsors, very importantly, the startup Tamil Nadu, Pulinam Aerospace, Altier, CATFEM, Infinity, Answers, and Bimena. Because I think everything we can organize, but we need to get the mementos, food, and so many items, everything we need a sponsor. Within 1 month, I think the seminar is organized. I think Answers has come forward. And definitely, thank you so much. I think you have taken so pleasure that being a name of IEA and IEEE, you have given that much of authority. Even I know it's some 3 months of procedure what you have, and you have given this 15 months. Thank you so much, sir. I think we want to continue the same journey with you in the coming days. And last but not least, the one-man army, we have to appreciate him. And can I ask Karnagaran to stand up so that everybody can give an applause to him? Because I know Karnagaran is something that's so dynamic, and he's my friend of mine of past 6 to 7 years. And we organized one big webinar during the COVID time. Just like I said, Karnagaran we was organized. He managed the complete show, bringing the speaker from the NASA, ESA, and JAXA. Such a network he is having. And definitely, I think you all people have to appreciate, take the encouraging words from him. With that, I think we appreciate all the people who have been directly, indirectly contributed for the seminar. From the heart touch of IEA, Tamil Nadu State Center, we want to take up the next level of seminars to be organized here, and we will do all this by the coming days. And thank you so much.
Thank you so much for being with us today. It has been a true honor. As we conclude this meaningful event, I extend my deepest gratitude to our distinguished guests, organizers, and all of you who have joined us today. Your presence has truly made this occasion special. Let's end our event with the national anthem. जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल गंगा विंध्य हिमाचल यमुना गंगा उत्कल जलसि तरंगा तब शुभ नामे गाहे तब शुभ आशीष मांगे जागे तब से जनगण मंगल नायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे